All right, let's get on here. Let's see what's going on here. All right, so what are we working on today? A few things. Let's pull up the Discord, and I'll show you guys. For anybody that's interested, we have a bunch of free events. In fact, there's one that's starting in 25 minutes, which is going to be security project intensive for people that want to go work on that stuff. We've got security engineering study group. These are all like group-led events that some of you guys have been wanting to work on and join. There's a bash study group on Saturday, so that's in a few days. And then there's a Linux sysadmin course, which is always free. And then there's a Linux security engineering course, which is also always free. You guys can go hang out down there. Do pretty much whatever you want. There's the writer's room. Those are the guys that are working on the books. The books are the kind of persistent web place for you to go to look at some of this stuff. And then there's your Git study group, and then also your bunch of other, look, a bunch of these ones are just popping up. I don't even know what they all are anymore. But go on the Discord if you want to check those out. What am I working on today? I've got to update my security presentation for the course. We did a meeting last week, but I have not recorded it yet. So I got to get Unit 9 done, and then I'm going to start focusing over on Unit 10 to be ready for it. So this is going to be the 9th class meeting. Last week, so the week before this, we had done, I have this to pull up. We had done two questions, and the first one had to do with configuration management. Right, configuration management, and then the second one that we were doing. Hey, thanks for the resubscription, never fear, Boris. We are just hanging out, and yep, definitely appreciate that. I know you've been around for quite a while and helping out with the group and stuff, so I always appreciate that kind of stuff. All I'm doing right now is updating some stuff, so we're going to do SRE practical advice. So this last one was SRE practical advice for security configuration management. And, oh shoot, I don't even know what I'm doing here anymore. That was last week. So let's go switch this to last week. And then we'll go this week. The stuff we're doing this week, we can throw that out. Get out of there. And Unit 9, so we were dealing with two things. Key management, right? So first one, the first topic of the discussion is key management and topics. And then the second one that we're talking about is TLS encryption and operation. Right, those are the things that we kind of worked on for the discussions for this week. Okay, the last week lab had been monitoring and alerting, and this one will be, actually that one had been configuration, is that right? Configuration management, I think. Let me go look. Let's see. Where's Unit 8? Yeah, configuration, drift remediation. That was Unit 8. I'm getting my days all mixed up, so it's actually kind of funny. But yeah, we're just working on this stuff. So that's last week. This week is going to be on the topic of, generally speaking, certificates and keys. So the lab is certificate and keys in the enterprise, right? So the overview. This is going to be what is encryption, symmetric, asymmetric, then we'll talk about how do we use How do we use public PKs and authentication? Let's say TLS operations. This is just kind of me thinking about all the stuff that we're working on. TLS operations. Let's go with what is encryption? We'll talk about asymmetric and symmetric encryption. We'll talk about to establish identity, because we use encryption and, well, we use trust to establish identity, but that trust is based on encryption, right? So we use the X509 certificates and what's commonly known as like PKI in our own infrastructure, but then how do we use encryption to establish identity? And that'll be probably referencing the really good write-up that we have from the Spiffy. It's called Spiffy. That's actually the name of it. Book. TLS operations. Yeah, that's pretty good for our overview for now. That's fine. So then let's come down here and we'll clear this up. And overview. Yeah, that's fine for now. So we'll say symmetric. So let's, well, we'll just add, we'll put in what we have. And then we'll just add in the stuff as we go. So duplicate that slide. Second one will be asymmetric. Huh, it's funny that it changed. All right, let's go find it. Where do I have that? I have that here. So I drew these up last night. Asymmetric and symmetric encryption. We can make this a little bigger so it fits. We're just going to grab that. Where's my stuff at? Boom. So we'll talk about what's going on in there as we're doing the course. Right, we're not going to talk about, we talk about it a little bit right now, but it's the idea that we create a tunnel. And with symmetric encryption, one of the things that we don't get is we don't get, well, we don't have any of the concepts of non-repudiation, and we don't have the concepts of non-replayability. We get those things when we use TLS later. But that's an asymmetric style of encryption, right? So let's go over here and let's pull this up. So asymmetric encryption is different because it's a public and a private key pair being used, right? And it causes us to have then this. So this is all part of our talk, all part of the concepts that I kind of go into when we do the discussion, which we already kind of had this discussion as a group. I just hadn't, I just kind of brain dumped on everybody, and we didn't really have all of this stuff to go with it, if that kind of makes sense. Boris, I mostly go, so mostly what I do is I just throw everything in here in one section called this is just Linux group, right? And then all of this stuff is Prolog, either the automation course isn't written yet, but the Linux systems admin course that we did, everything's in there, right? And it's all by unit. And then the security engineering course that I'm working on is all right here. So unit 1, 2, 3, 4, 5, 6. So if you were like, hey, does anybody have the original course syllabus? And I can say, yep, got it right here. Here's the original course syllabus. We can go and we can review it. However, the guys did a really good job, in case anybody's wondering and they're like, hey, how do I get a hold of this stuff? You know, I'm not part of maybe the normal group, but I still want access to it. The LAC, let me pull this up. This is the, oh, do we have the contributors finally? No, we don't have contributors yet. The guys that have been working on this, they've done a really good job. They've got this is just a free web book for anybody that wants it. So I'll drop that for anybody that needs it. And then here's the current version of the syllabus. If anybody was like, well, hey, what goes on in that 16-week? If I commit to going 16 weeks into this Linux admin course, what's that going to kind of look like here? And here's the things that you're going to do for the Linux admin course. These are kind of the topics that we go over for those 16 weeks. It's not one-to-one, 16. In fact, we're in week 10 this week, and we're basically done with all the way through 7, and then we're just going to keep hammering out some of these other pieces as we go. We just keep hitting a bunch of technologies. In fact, all the technologies are right here. All the things that we hit are right here. So 10 will be taking that Docker stuff and going further. We're going to do Kubernetes. We're going to do some microservice stuff and all that kind of stuff. Yeah, that's the Treasure and the guys put that together. Treasure was the one who originally recommended it because he had done some of that stuff with his notes. And then a lot of the guys just ran it. The PSC course, I always do that. PSC is, here's the intro, here's the course syllabus. So if anybody wants the security course, that's right here. There it is right there, and there it is right there. And then on the security engineering one, I think, well, let me not lie to you guys about it. I think they're going back, and as I'm recording each of them, they're putting them here. So there's me on the one about the first week, right? And then going through each of the different weeks. And then the last week, I was going to add 2 extra weeks, but I think the last week should be enough to kind of wrap it all up. I'm going to tie everything back to the security. So it's just going to be, I think it's going to probably be just the biggest review ever. But we'll see where it goes. And then, we got definitions and things that you need to go work on and all that kind of stuff as you go. Oh, yeah, check out something from one of the... Oh, wow. Okay. One of my coworkers was showing me one of his cool little, like a little wooded spot that he has where he was working between a couple locations, and he just had an RV on one of the spots, and then he had just kind of like turned it into his own little remote working site. It was actually pretty cool. But okay, so yeah, so here's the course. If you needed this stuff, if anybody needs these, I have these as PDFs, and they're up in the Discord. But also, we have them obviously over here, so you don't need that. But if anybody did need that and had a good compelling reason for it, I'd send it to you, or I'd just tell you where to go get it on the Discord. I'm not like super worried about that. So here's Unit 9. So we're on Unit 9. We're making stuff here. I'm gonna save this now so I don't lose all my damn work again like I did last night. And then what I need to keep doing here is I'm going to pop all of these off. Basically, these are all the ones from last week, right? Because I just keep moving everything forward. We don't need any of this. We don't need any of this. This was our deployment, like server deployment and that kind of stuff. And then we get to our review. Now, our review is always just a copy of our overview. So I got to finish up the overview before I can go further into that way. Or before I can go further down there. But let's say using encryption to establish identity. I guess I got to talk to each of these. How do public-private key pairs, how do we use public-private key pairs in authentication? And then our TLS operations. All right, so if I were to, I can't just make a new slide. That's one of the problems with this template is if I just make a new slide, it does this. I hate it. So what I do instead is I typically just duplicate a slide and then move it around where I want. So one of the first ones is, let's call this and so what is encryption? Right, so what is encryption? Should have a question mark on that. And then I have a different typically, do I have it in here? This is our where for encryption. I'm going to grab this whole block and go throw it over here. Nope. Encryption. Duplicate slide. You guys will find that I steal all kinds of stuff for myself all the time. Where when we encrypt? And we encrypt in all of these ways. Data at rest, data in use, data in motion, right? These are all the kind of important places to make sure that we're encrypting things. So data at rest, data in use, and then there's a whole bunch of, so a lot of times when I talk to stuff like this, I don't put everything on the slides. I talk to it as we go. So like data at rest, right? We do a thing called envelope encryption. Envelope encryption. I'm going to pull that talk over here as well, because that's important. But data at rest at a minimum in the cloud currently is AES 256 encryption. That's the type of standard for the encryption that we use. Data in use is as we're using the data, how are the data being stored in memory, and what are we doing it with that? So the specific types that you're going to use in the enterprise for encryption are anything up in the cloud, anything that's being left, let's say left somewhere. Your data at rest encryption standard is AES 256. Your TLS minimum standard right now is 1.2, but I would say 1.3 is probably the minimum that I would configure in any newer things like that, right? And that tends to be, so data at rest is your AES 256, data at motion is TLS 1.3, and data in use is really going to be based on what you what you can stomach in your organization as far as are you using masking, are you using granular permissions? We use what's called identity and access management permissions. That's not just, IAM is not just something that you hear from like AWS. That's a industry type standard of identity and access management. Oh, hold on, let me pull this back up. I don't think I need to pull all of these down. Here. So how do we? I'm gonna put this as this is all my old stuff, right? So I'm just bringing my stuff up, and then what is encryption? This is a pretty good description of encryption. So encryptions are based on ciphers. Pass plain text through a cipher to get ciphertext. Pass ciphertext through the correct cipher again using the correct method and get plain text. This effectively creates a tunnel between the sender and the receiver for confidentiality and for confidentiality purposes. Sometimes it also can be used for integrity purposes, right? So that's something that can go in there as well. Not Fake Amir said, hey Scott, I'm trying to learn K8s from scratch. Do you have any recommendations? Yeah. So let's say anybody here that's watching this, even if you're watching this later, you say, Scott, I've never touched Kubernetes and I don't have any, I have zero skills in Kubernetes and I want to start on them right now. This is how I would start if it were me. I would go to Killer Coda, which is a free website. I'd go right here. Get out of there. I'd go to Killer Coda, and I would probably start on CKA certification right here, right? So CKA certification, and here's about 130 scenarios that'll just drop you through. So that's hours and hours, maybe even upwards of 100 hours worth of things to go work on, right? If you've just never touched anything, and because here's the thing, right? This is always the barrier of entry to everything that I tell you guys. When I started Linux, somebody just tossed you a CD and said, install Linux. And if you couldn't install Linux, and by the time it came time to talk to the person again, they'd be like, well, I guess you can't be a Linux admin. And that was the end of the conversation. Well, what if I told you right now, hey, to learn Kubernetes, you got to go install Kubernetes? I guarantee you 95% of the people would drop out right there. They wouldn't even try. Because even if you did, it's extremely complex to get Kubernetes. K3 is super easy. Kubernetes, like from a working K admin, it's a lot of setup in the system. I mean, you got to go do some networking stuff. It's gotten better, but it's still a very complex process, right? Well, you could just drop right here into a Kubernetes environment with 2 nodes, 2 nodes Kubernetes environment right here for free. These guys have never charged me. I've been using them since like, I don't know, like September of 22 or something. They've never charged me anything. So I think it's really good. So now, hold on. Now to your question of basic concepts, right? This is the things that I would go do, right? I would say, okay, I can be at a command line and I can start typing whenever I want. But what do I type, right? Like now that I have a command prompt, what do I do? This is what I would do. If I were trying to get, into Kubernetes and I didn't know anything about it, I would come over here and I would say like CKA CKA objectives, right? And I would get something like this, right? So CKA objectives, hit enter, and here's your certified Kubernetes administrator objectives. And don't worry about paying anybody money. Don't pay anybody money yet. Just come down here to the objectives, and I would take all of these objectives. I would expand all. I would take all of these and I would grab them just like this. And I would throw them in OneNote just like this. Boom. All right. So now I don't know any of this. I'm at 0%, right? Like for the purpose of this example, I'm at 0%. I don't know how to do any of this stuff, but I know this is the stuff I need to be able to eventually put a little check mark by that I know how to do it, right? And then I would start to go looking at like the Kubernetes docs, right? Maybe I can go find all their concepts right here. So here's all their cluster architecture, all their docs and concepts. And I'm going to show you one other thing that I really, really like that I think everybody should do if they want to get one of these certs. I would just be sitting here at this command prompt, and I would go over here and I would say, I would do this right here. I would say CKA GitHub notes. And I would just find notes that people had done. So right here, somebody, let's see. I have no idea who this Nicola Gural is. I have no idea who this person is. I'm going to hit button right here. Here's a bunch of his notes. Here's all those sections again. So here's the cluster architecture. Here's the weights of everything. And let's just say that manage role-based access control was the first one. And he linked us over to here. So that's less useful. But maybe I could at least read about it a little bit. Let's see if some of these have really good examples. Let's go evaluate cluster and node logging. All right, he's literally just dropping us into the documentation, so that's cool. But some of these guys, they have really good, let's maybe even say practice, right? That's I'm pretty sure I've seen this guy's name before. And let's say that we wanted to do storage stuff to start. And he's got some cool docs, and then he says right here, question, create a pod and mount a volume with a host path directory. Check the contents of that directory are accessible through the pod. Okay, those are a set of steps that I can come over here and say, okay, well, I needed to make some storage. I needed to mount something into my pod. I don't even know what a pod is yet, but I'll figure that out as I go. And I can start to answer these and start to practice. Watch right here. He's got the solution. So I can take this right here, and then I could start to maybe mount something on my system and then go create it. So maybe on this system I have to make their home Ubuntu data, right? I need to do a touch of data file. So that's all the way, you got to be down in there. So home Ubuntu data file. That's what he says to do, yeah. And then now in here, we can mount this here, and we just vi maybe pod pv pod.yaml, right? Control-Shift-V to paste, escape :WQ, and then how does he say to apply it? kubectl. I like to do kubectl create, but everybody does it different. Apply -f pv pod YAML. It's going to create it, and then we can do kubectl get pods. We can go look. Is it running? Is it coming up? It's taking its time, but it looks like it's running. Okay, yeah, no problems with anything. Okay, good. kubectl exec pv -pod ls data, and nothing came back there. So that's less good. It's very possible. Let's see. Mount path data. Ubuntu home data. What do you make us put in there? We touched data file, so we should have seen a file out of there. We should have seen a file in there. Home Ubuntu data was mounted in data, so we should have seen in that exec. Should have seen that, but we can do -it, go in there, right? Maybe you've done this stuff, right? We can drop maybe sh and then ls in there, and then is there a data? And then no, I don't see anything in there. Home Ubuntu data. We definitely see that directory mounted on that pod, but then why didn't it mount? Name data / data. Home Ubuntu data. Oh, I'll tell you why. It's because, well, probably because it's mounted. It's probably owned. No, that doesn't make any sense either. Anyways, the point is you could do all that stuff and you could make all of those things and you could go play to your heart's content. And I would say probably if you spend 200 to maybe like 300 hours in there getting familiar with stuff and answering all these questions, then you'd start to be ready to go take one of those cert tests. That's what I would say. If you just, I think you said you have no basic background of it and you wanted to go. Yeah, I would absolutely do that. Well, because here's the thing, right? Because you can do all of this, and then if it were me, I'd be taking all these notes. I'd be writing down like I don't know what a mount is and a volume mount, and I don't know what I don't know what this API version 1 is, and then I would go read about it later. But it's kind of like one of these things where, like I always tell you guys, this is an example, but it's a really accurate example. If you have two friends and your two friends are getting big and strong and, all the girls are checking them out and stuff, so you're like, shit, I want to go hang out with them and figure out what they're doing. They're not going to sit you down in a locker room for 6 hours and tell you about the gym. They're going to make you go follow them around in the gym and have you go lift weights with them. Later on, after you're sore for a few weeks or a few months, you're going to be like, oh, okay, yeah, I see. Today we were doing push and today we were doing pull, and that's how like all my muscles feel from all these workouts that we're doing. So I'm a big fan of doing things and then going back and understanding later what you're doing, right? Anyways, all right, so that's my thoughts on that. All right. Well, encryption are based on ciphers. Pass plain text through a cipher and you get ciphertext. Okay. There's symmetric key encryption and asymmetric. We tend to use them for those reasons. When do we encrypt data at rest, data in use, and data in motion? So those are all things I want to talk about with the guys. Symmetric encryption looks like this. It's a little harder to see, I know. Hold on, I'm going to pull up. Let's pull my other one up real quick. So, real quick, let's make sure there's anything. So that's all true. That's all. Public key infrastructure is not. They're not the same thing. SSL and TLS. But since SSL and TLS come from your use of public key infrastructure, that's where they're kind of related. They're not, I guess I would say, related other than that. One deals with authority and the other one deals with. Let me go. I'm gonna make this big again and put this in the background, right? Because this is my background that's doing all my closed captioning. Let me pull this other stuff up front here. And then we'll get back into the stuff that we're building. So, which is the course. So symmetric encryption looks like that. And, you've got plain text on one side and plain text over here. But in between, you've got ciphertext. And the same key can be used on either side. Like it's like a little decoder ring. If hello becomes that, over here it becomes hello. If it comes back out this way, if I happen to pick the message back up, I can read it again. Whereas asymmetric encryption, when I go through a public key and I make that ciphertext, there is no way to come back to that original text through that public key. That is a one-way cipher. I don't know if you guys have known that or knew about that. That only goes one way. And then it can only come out over here with the related private key. That's the only thing that can decrypt it. The public key can't decrypt what it makes. It doesn't work like that. Hold on real quick. Okay, it's such a server. Which cluster is pretty much a small server that holds nodes. Yeah, no. So the 24. Yeah. What happens is, hold on. I can answer that. Hold on. That's a good point. Let me just pull up something else. Since I'm not super. Where's virtualization? Where's my virtualization stuff at? Somebody help me out here. Find my virtualization. It's been too long. All right, let's go look at my virtualization stuff real quick. So this is my little virtualization talk, and I'm just gonna run real quick through this. We're not gonna go super deep, but we virtualize. Here's normal virtualization. We have hypervisors, and then we have a type 1 and a type 2 type hypervisor. Type 1 are the ones that we use in the industry most of the time. It's a bare metal machine hypervisor guests. Type 2 hypervisor, bare metal, some operating system, then you start a hypervisor, and then a bunch of guests. So there's a layer of abstraction there that causes more of what we call a footprint of attack and all those kind of things. This is great for developers. This is great for when we productionalize things. So hold on real quick. Hold on. It does fake Amir. You just have to go. I have to go off of studio mode. When I turn off the studio mode, I think it turns on. So it pops up like that. If anybody asks me stuff, it says I can answer that for money. But there's two things that actually have to happen. That, and then I also have to have the streamer bot on, but I don't have streamer bot on right now. So, Abdel over on the YouTube side, thanks for being a ProLug member. I don't even know what that means because I don't do much with YouTube. I just kind of upload stuff to YouTube, but I think that means that you get access to some of the other stuff that I'm going to be putting up there soon. So that's kind of cool. Let's go to hypervisor real quick. Containerization with pods. Containerization before we even got to pods, is this idea that when we were doing all of this with virtualization, we were building these big virtual machines and they were very bloated. They were not super efficient. But then with containers, we can just have a container running inside of an operating system and we could be very, very highly efficient. So it's kind of this question right here of, I put one physical machine on one piece of hardware and I say, is it full? And you go, yeah, that's all it can take. And I say, but then I can virtualize it. And you go, yeah, now it's full. And I go, but I can put containers on there. And you go, okay. So we can keep getting more and more granular. In my home lab, let me show you guys something real quick. In my home lab, let me reconnect to everything. So I use this VPN for one of my customer contracts, one of my government contracts that I work on. And because I use that VPN, this is constantly kicking me. This thing is constantly kicking me so it kicks me out of all my home local stuff. But I want to show you guys something real quick. In my home lab right here, right, this physical box, let's go with this one. He's got 26 nodes running on him total because there's streamers, there's all the other ones. And let's see how much performance he's using. He's one physical machine with 26 virtual machines on him. And he is chilling. He's not even at 10% usage. Chilling. Now, let's go up here to this cluster, this node here. This is, this is a physical machine with virtualization on it. Let's go to his performance. He's chilling. He's about 10%. And he's got, I don't know, let's call that about 12. But these machines right here, the prod Kubernetes cluster that I have, my production Kubernetes that runs our website and other stuff like that, that is running, I don't know, if we had to go look, it's probably somewhere around 40 or 50 containers. And I could probably run about 400 containers on each of these, and we would still see this thing chilling. Did you say 400 containers? Yes, 400 containers on each of those. So I could have, but in Kubernetes we call them pods because the pods can have multiple containers inside of them, and then we don't have to worry about that other stuff. But anyways, my point is, inside of here, we can just keep squeezing out more and more. So no, containers are highly, they're packageable and they're movable, kind of like big containers on a container, like a cargo ship. And then they have just the binaries and the libraries that the app needs to run on whatever container runtime that you have. Cryo, Docker, Docker is much less common. Cryo is much more common. Container D is much more common nowadays too. and then we go into all that stuff. All right, anyway, so that's not really what we're talking about or what we're working on right now, but the question was around that. Abdel said, really appreciate the content. Yeah, hopefully this stuff's useful to you. Junior sysadmin and that kind of stuff's very good. That's a good place to start. Looking to build solid foundation skills for sysadmin. What would I recommend to start to get up to speed? All right, Abdel, I will tell you, we have a really good group of people. That's our professional Linux users group. Looks like they just started, by the way, the security engineering project intensive. So they always have stuff going. These are mostly groups that the guys have started and things for people to study. So you've got a place to go and talk with other engineers. That's a thing that I think is important, admins and engineers and people that are doing this stuff. Then the other thing that I would tell you is, you can always challenge yourself with a cert of some type. You don't have to go take the cert, but at least go find something that you want to study. We have, I wouldn't really call them certifications, but we have courses that we run where you can go and do kind of like a 16-week course, and these are the topics of the course. It's free, doesn't cost you anything. It's just down in the Discord, and just go start working in there on, getting into Linux, and then start working through these different topics for being an administrator. This is specifically the things that I think an administrator needs to kind of know how to do in today's world, right? There's worksheets and there's labs and then there's discussions, and you can go read the discussion posts that people have made and all that kind of stuff. All right. Yeah, Mint, you're right. They do. In fact, that's an important concept. You can very rarely containerize something on a Linux box and take it directly over to a Windows box and make that work. The underlying container platform still typically has to be the same. There's probably some exceptions to that, but I wouldn't sit around and like spend any time with them, because they're not going to be something that they're what we would call like a severe edge case, and most people don't need that. They just companies need stability, right? That's what you guys are going to find is, if you've ever seen the movie Doom, where The Rock is walking around and going, I just need soldiers. I don't need this and this. I need soldiers. And it's really funny because he's a Marine. And so like, that's funny because I was Army, and like Marines will never call themselves soldiers, even though if you were to argue with them that the act of being on the ground in a combat zone is to be a soldier. But anyways, it doesn't matter. Here's the security engineering course. This is the other thing that I would say. But I would tell you, if you're already in the industry, I would say the most important thing to do is just keep soaking up and staying good at what you're doing, and finding the technologies that you work with and becoming experts in them. Because I tell people all the time, if you're a Linux engineer or Linux admin, you have no idea where that next company is going to put you. They're going to put you in with maybe 30 little Linux boxes and just expect you to wrangle a bunch of containers. Or they're going to throw you in, like I get thrown in a lot with high performance compute, and I'll have 16,000 systems. And they'll just be like, well, all the systems have this one problem where like NFS doesn't stay up. And then it's like, all right, well, we'll go figure out this NFS problem. And then that's what I'm doing for the next few weeks or whatever we're doing. So, Mint, yeah, we have a lot of people. Yeah, and that's the guys making their own study groups. I'm not doing that. I'm not making anybody go and study or telling people they have to do that stuff. They're just doing that because they want their projects to be really good. They want the stuff that they the stuff in these projects that you guys are making should be good enough to go show a company, right? And because there's two things you want to be able to do in an interview, right? You want to show the company that you can do the work, and then you want to show the company that you will do the work. Well, can you do the work? Most of us know, most engineers know within about 2 minutes of talking to somebody if they're operating at the same kind of wavelength as that engineer. And people are like, no, you can't possibly know. Nope, I'm 100% positive. I've been doing this long enough. All the engineers I know have been doing this long enough. I'm very sure that like you just kind of know. And if somebody's not operating at the same wavelength, maybe that's a bad vibe for the team. Maybe that's whatever. But then the other one is, can you do the work? Or can you do the work's easy. Will you do the work is very hard to quantify with people. Does somebody actually like doing this? Are they going to take this seriously? Are they just going to be a dirtbag and it's going to take us 3 months to get them out of the company? There's all these things which, by the way, that's one of the reasons so many companies do contracting in this space, is because it's easy to get rid of a contractor. Very, very hard to get rid of a full-time employee, right? So The reason I bring that up, the reason I talk about that like that, is it's important to kind of be able to present this stuff and show a company that, hey, like I not only understand this, but I also enjoy doing this, right? And I think that that's something that I almost want to say is intangible, but it is something that you can at least sit through and work on. All right, so asymmetric encryption. Then we get down to review. So we're not reviewing that. We're definitely going to review this. Whoops. Oops. I don't want to do that. Where's the review? Overview. Let's grab this. Down here. View. And then if I end up adding anything, I'll just have to add more to the review later. But okay, so we've got what is encryption? What is encryption? When do we encrypt? How do we encrypt, right? So these are how do we encrypt, basically, symmetric and asymmetric. And then, and then we're going to go into, so we'll do use encryption to establish identity. Just do this one. Encryption for identity, and the concept there will be okay, so real quick, a concept of like multi-factor authentication is you can have something you are, which is biometrics, like your retina or your different types of scans, your fingerprints, things that are very hard to track. That's one part of multi-factor authentication. That's what we call one factor of authentication, right? Now, another factor could be something you know, so like a password or a passcode. But another factor of authentication that's very common is something you have. So having the key establishes who you are. So protection of the key is paramount. Paramount, not like the company Paramount, but to be the most important thing, right? Having the key establishes who you are, so protection of the key is paramount. Keys are stored in the most restrictive permissions that still allow for operation. I can prove that right here. So go into my screen. We go right? And these were two keys that we had made during the lab, and we're going to just show that. And then we can always talk about that, but the idea, oops. Let's move this up a little. We're gonna have to move this around after I keep typing, but that's fine. So, if you're not familiar with ACLs inside of Linux, that's a thing that you need to get good at if you want to work in this space. But this is our private key, and it is in a 600 permission. It's set up in 600, and then the public key that can be shared far and wide is 644, which is world readable, right? That's a world readable file. So those are kind of important things. So having key establishes who you are. So protection of the key is paramount. That's true. Keys are stored in the most restrictive permissions that still allow for operation. And predictably, government best practices for key management that can guide your organization. Now, you do not have to use, like a lot of times I tell you guys with government stuff, there's really awesome things that you can go cherry pick the things you want out of. One of the hardest things you can do, guys, and you may or may not believe me, but I'm going to prove this here real quick to some of you. If I said, okay, let's write a security policy for how we're going to like keep keys in our organization, and then I pulled this up right here in a meeting. We're all in a meeting, and we're like, here we go. And I just start typing right here. This would be extremely difficult to start. To get the scope and encompass all the things that have been thought about by other security engineers over the last 40 years of this stuff, especially in the Unix space, almost 50 years in the Unix space, right? You're not gonna outthink them with a little group in a few minutes. What may be better is take your organization and say, and I propose that this might be a little better. Let's get out of here. I may come over here and say, well, what if I go here? Where is yeah. And I go to NIST 800-57, and I go look at their key management that's already there. And I say, well, they've got a pretty good little setup of maybe how I want this to start out, right? This recommendation provides cryptographic key management guidance. It consists of 3 parts: general guidance and best practices for the management of cryptographic keying material. Well, that's awesome. Tells me what to do. Then again, you're not beholden by like this is just a network. This is the National Institute for Standards and Technologies. It is just their recommendation for key management. You can go take as much or as little of it as you want. Here's the actual thing I wanna do. That's I don't want this other thing. I don't care about that. That's the one I want. All right, let's move that down. And then maybe you go in here and you start off and you say, okay, what are some things that would be good to know about keys, right? There's basic key management, and after you then maybe pick the things out of there and maybe scope and outline, then you change some stuff around based on what you learn in here, right? So there's that kind of stuff. Bottleneck, fix it. How's it going, guys? We're just working on. I'm putting together the Unit 9 presentation that I have not recorded yet. Normally I record them on Sunday morning for you guys, but I haven't done that. I haven't gotten around to that yet. So, but yeah, that's what we're doing right now. So come over here, encryption for identity. There's some things there to think about, and then let's duplicate that slide, and then let's say encryption for trust, right? So encryption for trust is oops. So who you choose to trust, or who your system trusts, is based on authority. Authority can all right, be signed from a certificate authority, and then your systems trust things that have been cryptographically signed by that authority. We call these certificate. It's kind of a proper noun, but we don't need to capitalize. I guess authority can be signed from a certificate authority, and then your systems trust things that have been cryptographically signed by that CA, right? So these are called certificate authorities. Authority can be signed from a CA. Your systems trust things that have been cryptographically signed by the CA. This trust is tested by a public key that is downloaded from the CA. So this trust, let's say this trust is tested with the following steps. And actually, that's not the first thing. Even before that. I know, I should be able to just use the numbering, but I don't think that's going to work on here. We can try it. For some reason, my numbering never works. All right, but before that, yeah, all right, that is going to work. Good. Yeah, fix it. I tend to think my stuff's pretty good, but the best thing about my stuff is probably that it's free. But then also it's been vetted by a lot of people who are in the industry that do these things. Most of the guys that are in the server, people that didn't meet me through Twitch and YouTube, which there's a few hundred of them, they just know that I've been doing this stuff for a long time, and they tend to think that I at least kind of know what I'm doing. At least they keep, sending stuff my way to work on. All right. Your system, and I have this visually right here. So your system initializes communication. Hold on, shoot, where'd my other thing go? Back over here. Your system initiates a communication. Right. And generally, that's how it works right there. Probably another couple of things that we could work in there, and there's a little bit more in the handshaking part of it. But generally speaking, that's what happens, right? That's kind of how the trust of that thing is built. All right. So we have all that. We have this. Somebody said, hello, I'm new here. I was wondering would do deeper encryption vaults for SSH or BGP keys compared to the password files and links such as a shadow file. Do we have deeper encryption vaults for SSH or BGP? All right, so Bowman, we can, so from an encryption standpoint, we can do all kinds of other things to make those keys and the things that we have, right? Because that's one of the multi-factors of authentication that exist. Something we have is just one of them that we can use. And the key there tends to be something that we have to have and be ready to use. The private key that we keep for ourselves if we're using SSH encryption. What I would say then is, can you do something like a one-time use key where you check it out from like Vault or something, and then you get the key and then you use the key one time or for 10 minutes or something and it goes away? Absolutely. We could do, there's so much structure that can be built on top of that. And man, like all the things that I have to like jump into to get to my different customer accounts and stuff, it's absolutely wild to me. But one of the things, I mean, when we talk about like your appetite and your risk appetite and then your security of systems, we tend to go, well, how many factors of authentication do we want? Okay, if we're going to allow keys in, that doesn't have to be all. We can also say, so that's something you have. We can also say, okay, now you need something you know, which is also the PIN that goes with that key. By having that key, you only have half of the factors of authentication needed. The other one could be something you know, could be a fingerprint, something you are. When I go into my data centers, I have a badge, that's something I have, and then I use a fingerprint, which is something I am, right? Or something about me, right? So those are the factors. So my point is, the way that we expand these out, because we still have to be able to present information out, and then we still like our key has to still exist somewhere, is we have to lock that key down again according with like our access control list policies and other things like that. But no, typically for me, if and this is what this is the way the industries went, is if we're trying to be even more secure, we just add more factors of authentication. In fact, I have one that's kind of wild. There's a customer that I have that does medical, and when they message me, or when I log into their stuff, it's my username and my password, so it's something I know, and then they call me on my phone. They don't text me. They don't use a multi-factor authentication. They call me on my phone. They don't text me. They call me on my phone, and a voice, an actual voice, robotic voice, says my password, my PIN twice. So there's like a 5 or 6 character PIN that I have to then type into the thing. So now that's something I have, which is my phone, and that provides me another something that I know. But it's really, the test for authentication is actually, do I have the device? Which can also be accomplished with, if you guys have ever like gone into GitHub or something like that, and then you have to use like a Google Authenticator, or some of you guys use YubiKeys. I work for NOAA. One of my many government projects that I work on is NOAA, and they have YubiKeys now that we're going to be using. So it's like just more things. And you say, well, isn't it bad for people to know? Well, no, because now they need to also like either have my fingerprint and have my YubiKey, or know my PIN and have, you know, and there's these multi-factors that make it more difficult for these things. So anyways, where I'm going with that is, you can do all kinds of things, and you can play all kinds of things with where you go and check your key out from and how long a key exists. But then there's also, you know, this idea that, well, there's all these other things involved as well, right? So it goes, it came back from log ad, and you mentioned that all the classes staying open to get the cert at your pace as long as the discussion posts. Yeah, man. So for people that do these, right? These are free, guys. By the way, the Professional Linux Users Group Linux Admin course is free, as is the security course. And there's a cert that comes with them, but only if it's basically only if you do it with us. Yeah, that we're doing that cert. And the reason for that, a lot of people might go, well, Scott, I'd like to just crash through it in a weekend or something. One, I think it would be very hard to crash through all the work in a weekend, because I designed the courses to have about 10 hours a week worth of work. And there's a few reasons I believe that, but one of the main ones too is like, you can't crash through, you can't like get your 6-pack in one weekend at the gym. You have to spend, months and months and years getting to that. And I think that's kind of the same thing with this. Like, the material, the focus for each of the weeks, and then having the discussions and talking to the people and then working through the things, I really do think there's a value in that. And you guys will find, like, if you ever talk to me about it, I've been a college professor for going on 17 years now, and I'm a big fan of college. I think college will change your life. That being said, I don't think you need college to do any of this stuff. But if somebody was like, Scott, on your recommendation, should I go to college or should I not? I would absolutely tell you to go to college. And I tell people all the time, like, you can say, oh, it's just a piece of paper, but I guarantee you anybody that's ever gotten that piece of paper doesn't think that, right? It's only people that don't have that piece of paper that think that. Or I would say, as a very small subgroup of those people, maybe people who didn't study or learn anything on purpose while they were there. Because I've dealt with over 5,000 college students. I know some students don't want to learn anything. Can't teach somebody that doesn't want to learn. So let's say that small little subset thinks that it's not worth anything. But people that went in and learned and went through the process, I think those people would never agree with you that it's just a piece of paper, if that kind of makes sense. Very similar process to that. I'm a black belt in Brazilian Jiu-Jitsu, right? I mention that sometimes. You go fucking buy a black belt, You go buy a black belt from an 8-year-old in a karate dojo down the street if you want. You can go buy a one on Amazon and have it tomorrow. Wouldn't mean nothing. You go put that belt on and go to a grappling gym and see what happens, right? And people are like, it would happen to you, I promise. But the point is, like, the belt itself doesn't mean anything. It's the process that got you through it, if that kind of makes sense. So where I'm going with that is the certificate that goes along with the course, it doesn't, in and of itself, it's the process, I think, that is of value to the people. And I think the people that have that cert and can say that they went through it are like, damn, I learned a lot through that. And it's not necessarily because I did this course for them. It's they had to sit and study all this stuff. There's all kinds of stuff that you have to study to even scrape the surface of doing this stuff professionally, right? So, anyways, that's that. Twin was sensor day center fingerprint. Absolutely, Bowman. Yeah. If a twin comes in, it doesn't match. Yeah. Mint. Yeah. So typically, what I do is let's if we pulled up a calendar somewhere, let's go like calendar. Let's see if they have a good. Let's go to just an image of like a 2025 calendar. Do they have a good? Hold on. Anybody have a good calendar for me here? Let's see what this looks like. Can I just open the image in a new tab? Yeah, they'll never let you see it, right? All right, hold on. That one's probably gonna look like shit too. Yeah, anyways, yeah, normally what I do, so to answer the question, Mint, I would say, yeah, I typically give you guys another week or so after, and we're in week 10 starting this Saturday for the admin course, so you would still have like 7 weeks to turn it in if you were turning stuff in. It is 2025, isn't it? MSEC, we are just working on a course that I've been doing for the security engineering guys in the Linux world that want to do more security stuff. I'm on Unit 9 of a 10-week course for them. This week is dealing with certificates and keys, and it talks about encryption and the different components of like what we do with keys and what it is to have an asymmetric key, what's the value of it, and all that kind of stuff. So that's what I'm working on. You had said before that the LSA was going to get a different color cert. No, so typically, well, I don't know what I said, but I can tell you that if we go to the Linux group and we go to like I think it's my streaming stuff. Hold on, it's called streaming. These are things that I was sent by, where are the images? Some of this stuff was sent. So there is this certificate right here. Let's just open this, see if this comes up right. This is the certificate that I think we're not going to release right here. This is the one that was never released, and it was going to look something like this. Whoops, and it's funny. It's got Thomas Edison as the signature, but then it has a little verify there, and I know that Treasure built this so that it automatically generates those. And then if you were to scan that, verify for a real one of these, this is just an example one, it would look like this. So if you came to prolog.org, which I'm hoping comes up here. Let's see. I gotta go. There's a cloud. Yeah, there's a cloud front. Give it a second. It'll come up. When that comes up, you would go ahead and you would drop in there, and then it would show that you had that connection. We'll give it a second. There's a AWS CloudFront setting that I have to go change. I just haven't done it. I know I keep saying that. But anyway, so we can go over here to verify, and then if I knew my name, and this would be built right into this verify, and then you would hit that, and then you would see that, give it a second. You would see that I was the one who would receive that certificate or whatever. Yeah. And I'm not wearing my glasses either, so that's probably part of it too. So I probably look completely different than some of you are used to, because when I'm wearing my glasses, it's totally different. Yeah, so anyways, here's my valid Prolog admin course instructor from last, actually it ended at the beginning of this year. And then somebody could then prove, so this hash right here would always be good for my user. And then we have other users. I think I have another one like here, Trevor. right? He was one of my other examples. And then I could go see that, yep, there's his stuff. So if somebody were to ask, did he actually earn it? We have a database of all the people that actually finished. And in the first course, we had like 208 or 209 people say they were coming. And I think we only had like 8 or 9, maybe 10. I think it's 8 or 9 that actually passed the first course. And when I say pass, it's not like I'm grading you guys super hard. I mean, it's more of like, this is for you guys, right? If you turn me in something that's just like, I'm not going to go through people's discussions, but some people's discussions are obviously more thought out, and some people's discussions are just like, I agree. Well, I mean, you get out of it what you put into it. When we're all done, and by the way, most people just fall by the wayside anyway, so it's not even an issue. But if somebody thinks that was enough to earn the certificate, then I mean that's kind of on them, right? I mean, if you think about it. So Bowman said, lastly, Professor would tell us to avoid Network Plus. So, man, that's a good question. So you said, should we avoid Network Plus? It seems that other people say we should push towards cloud security and DevOps. Well, my thoughts on that are, let me tell you how my career went. I was in the Army and I did my CCNA because I didn't know any better. I just did CCNA. So I never had to do like the Net Plus or the A Plus or anything because I had my CCNA, and A Plus I know is completely different. But my point in saying that is I didn't have any desire to do any more desktop work. I had already done a bunch of desktop work when I got out of the Army. So where I'm going with that is find something. I would in today's modern day and age, I would find something I'm really interested in first and then go study that. Whereas I was just like in the Army and just wanted to do some college and stuff. So I started like hitting my CCNA, my Cisco stuff. And then when I got out, I worked in Cisco I was a network engineer for probably close to 5 years, and I just didn't love it. I did it. I tried. My networks always worked. And I'm like, all right, well, I'm bored. So I didn't I don't want to say that it didn't challenge me, but I mean, it just wasn't, it really wasn't for me. And then I found in systems engineering a lot more things that were of interest to me with Linux. Like there's a lot of security stuff, there's a lot of storage and speed, and just you're way closer to the operating system. So that's kind of where I ended up spending a good portion of my career now, probably the last 20 something years in heavily Linux style systems, right? And then from there, I got heavily into automation, especially with Ansible and Python. I did a lot of Bash and Perl early on too, but nowadays you're probably gonna, if you look at any of my stuff nowadays, it's almost all Ansible, right? Almost all my automation's in Ansible. Anyway, so where I was going with that was, the question was around, would I avoid Network Plus? Look, if Network Plus is going to get you the job, I would absolutely study for Network Plus. And if you have, this is what I always tell people, right? Let's pull up a resume real quick. Let's pull up my, hold on, let's go back to documents. Let's pull up the Het Tanis approved resume for Stream. Where's my Het Tanis approved resume? Where it is. Here's my approved resume for Stream right here, right? Nothing on there that you guys can't see. Nothing on there that's not real. Get that out of the way. All right, some generic one. This is 70 now. Now 70 labs. But what I would tell you is if you had nothing on your resume, if you had nothing to put on your resume, I would think anything that's what I call a positive differentiator would be good to go get. So where I'm going with that is if you say, Scott, I finished high school and I've been like, I don't know, cutting bagels for the last 3 years, but I'm done cutting bagels. I'm 21. I'm done cutting bagels. I also play with my, I do Linux at night and I play with it, and I have 3 years of experience in my own home lab, but I want to get like a little more like formal type stuff. I don't really have anything to put on my resume besides maybe some lab work. Then I would tell you in that case, anything is good. Net Plus would be awesome. It would at least show that you went and got something. That being said, I don't think you necessarily need any of those things to get in. If you could prove through maybe your work and your diagrams, and even if you did, look, this is going to be really silly what I'm going to show you guys here. But if I had nothing else to show somebody, I would absolutely fucking show somebody this. Right, this right here. This is our home lab environment, right? And people do all these little funny dudes on top of it. But I would absolutely put that as my portfolio of how my home lab looks if I didn't have anything else to show somebody. If they're like, Scott, you got 5 minutes to convince us you know how to do Linux, I'd be like, well, this is the home lab. Here's a bastion up front. Oh, you don't know what a bastion is? Well, let me tell you, right? We use a Linux jailed environment, bring users in. Users then get to choose only the host that they want to go to, and they're shotgunned off into a bunch of these different Rocky and Hammer servers. These are cluster managed by a tool called Werewolf. Werewolf's a cluster managing system. And I would just sit there and talk to this if this was all I had. So where I'm going with that is find the things that are positive differentiators for you, and then lead with your strengths. In my estimation of, I guess, my own skills in doing this, this is where I think my summary of qualifications and kind of certs that I've got and things I've done, I think that's the most valuable thing. Then if somebody wants my titles and things and things that I've done in the career, this is not even, I need to actually update this, but visiting professor, then back all the way to, as 10 years back. This is actually 16 years back now for things I've done. And then the last thing that I put on my resume, because that's the thing that I value the least for people that can do Linux style work, is all of my degrees. And these are real. This is not the actual names of the colleges, but those are the real dates of my degrees right there. Right? And this is my cleaned up one for streaming. But the point is, if you don't have anything on your resume, I would get a Network Plus. There's nothing wrong with it. But let's just say you don't like networking. I would maybe not get a Network Plus because there are other ones. So if you said, Scott, I'm really interested in doing cloud, but then that cloud stuff would be maybe to get me ready for Linux, then I'd say, well, the AWS cert for the certified cloud practitioner is only like $75. I think it might be $100. It's like, that's a pretty cheap cert. And when I call that cheap, I'm also going to say that you can go and you can look up in your local area. I don't care where you're at in this world. There is going to be an AWS group somewhere, or some little cloud security group, or cloud group of some type. And they will have every few months a little event that you can attend, and then they'll give you a free voucher for a CCP, certified cloud practitioner. I guarantee it. And some of them even do them virtually, so you can just go sign up from anywhere and do them. I see those all over the place. Like, I think like LinkedIn's like one of the worst places on the planet. The only place worse than maybe LinkedIn is like Reddit, and then I'm sure 4chan, if that even still exists or whatever. But like LinkedIn's so terrible to me, but sometimes I see stuff on there that is kind of interesting that's like that for people that are trying to get into this. MSEC said GoPro Slow Yo showed me something a while back, and I've always pointed newbies to that. What's the MSEC? Do you mind posting that down in the Discord? I don't know if you're in our Discord, but I always tell people if you go drop it in the Discord, I'll pull it up, right? But it doesn't. The link doesn't come through. Fix it. You were at an AWS meeting a while ago, and they didn't have any free stuff. I mean, I can never tell you like exactly what the industry nowadays is gonna be like, right? Obviously, things can be changing by the minute even. But last I had checked, there was a lot of that kind of stuff going around. And then this will be my risky click of the day, whatever MSEC drops in here. Let's see. By the way, guys, the bot will say hi to you, and the bot is not always super nice. Let's see. People are doing admin talks, so there's admin discussions going on. People are in there. That's always good. All right, let me keep going with this. Encryption for trust. And then encryption for identity, encryption for trust. What's my last one? How do we use public-private key pairs and authentication? Yeah, they establish identity. Okay, so that's fine. And then some TLS operations. So I might do... So what's TLS doing? What is TLS doing? Let's go look at this risky click of the day. What's the risky click of the day? Security topics. Oh, the roadmap. Okay, I've seen this before. So this is what was dropped in, was like a roadmap for, I guess in this case it's cybersecurity, right? I'll link this to people. Let's go look at it. Let's see how good. Let's see what we like about it, right? They've got certifications. They've got advanced certs. They've got virtualization technologies, things. Yeah, I like this as a getting in there. Look at all this stuff. Security skills and knowledge. I think that's all useful. Basics of cryptography, salting, hashing, key exchange, private versus public keys, PKI, obfuscation. Yep, those are all the things that we're talking about. That's good. That's good. Yeah, there's all kinds of things going on in here. I like that. And all of these things, you know, you got to find what's interesting to you guys. I'm going to tell you right now, like if you tell me, this is one that I always use as an example. Let me show you this. I have college students that come to me. I still have college students to this day that do this, right? And the college students will say, I hate this. Like this thing right here, I hate it. I hate being at the command prompt. I hate like doing all this stuff. And they might not say that in so many words, but their work definitely shows they hate it. Some students have like vocally told me I hate this stuff. And I go, that's one of the worst things I've ever heard in my life. So, you know, you're 2 years into a 4-year degree, or you're in your third year. Typically, if you're getting to me, you're typically in your later classes. And it's like, wait a minute. So you're finding out now that you hate this stuff. This is the job. This is what we do all day. Literally, I'm not making that up. This is literally what I do all day. And if you guys thought, oh no, he's doing something else. No, this is literally all I do all day. And the only time I'm not doing this is when I'm switching between this for different companies. All right, jumping into a different VPN to go do some other thing. That's the only time I'm not directly in a command line all day. So that being said, if I hated it, sucks to fucking be me. Sucks to be me. So, you know, well, that sucks to be me all day because all I do all day is that. But where I'm going with that is, wouldn't a super good value be to like, even if you joined our Discord for like, and guys, Discord's free, so I'm not selling anything here, except that maybe you go check that out for like a few weeks and then you go, I hate this. Well, that was free. That didn't cost you nothing. I would rather find out that way than 3 years into a college degree. Because I'm telling you, like, I didn't love Cisco. I got a CCNA and I was doing Cisco stuff for like 2 years when I was in the Army. And then when I got out, I did that work for a few years. And I never really loved it. I just was like, I'm going to go do something else. I'm going to go be a Linux guy. So I tell you guys all the time, and you may or may not believe me, I learned all my Linux in the wild. I didn't learn it. I had one college class on Linux, and it was like CD, PWD, and LS. It was probably what's encompassed in this week right here. My whole college class, right? So I didn't learn any of this from that. All right. Anyway, so let's get this out of the way. Where's I going with that? Security stuff. I think that's a fine primer, right? Like I think that's probably a fine place to start. And this one of these things, it always reminds me of, you guys know who Lewis Carroll is? Anybody here not know who Lewis Carroll is? I bet you know his books. You might not know his name, but I guarantee you know his books. If you don't know his books, you definitely know one of his characters from one of his books, and that's Alice, right? Alice from Alice in Wonderland? No, Lewis Carroll didn't write. C.S. Lewis wrote that. Pretty good. That's pretty good. No. Lewis Carroll was Alice in Wonderland, and she asked the Cheshire Cat which road she should take, and he goes, "Well, where do you want to go?" And she goes, "I don't know." And he goes, "Well, then any road will take you there." And that's one of the. It sounds kind of corny almost, but it's deeply profound. The more you think about that, like, well, if you don't know where you want to go, I'll just tell you to go down that road. Just go over there. Go right over there. You'll love it over there. And you're like, I don't love it over here. Well, then pick where you want to go and find it, right? Anyway, so that's all that kind of stuff. That's me on my soapbox right there. I try not to get on my soapbox too much, but sometimes I get on my soapbox and tell you guys. It's funny. The Cheshire Cat is literally in a tree talking down to Alice as a cat would, and I think that's hilarious. But all right. So where else were we at? We know that kind of stuff. TLS operations. So let's go to NIST TLS. We have the NIST TLS standard, so it's 800-52, And I actually make the guys talk about is this right here? Supersedes that. Here's the doi.org. And this is guidelines for the specific use of TLS implementations, right? And we come down here, and they talk a little bit about how we should be on TLS 1.2 at a minimum. 1.3 is preferred, right? They talk about not using some of these other ones and require support for TLS 1.3 by January 1st of 2024. Well, that's a bit dated. That's a year and a half ago, right? Which is a long time in the internet world. And then we come down here, and here's a little history of TLS and how it works, and some probably really good terms for people to pick up and read about. People still refer to TLS as SSL. You'll still see it in the bottom of browsers and stuff, but it's truly transport layer security. SSL itself is not being, the secure sockets, SSL, has been gone for a long time. All right, they talk about blockchaining and the different things that happen. And we come down here, and here's an overview. There's a handshake protocol. So there's the session connection, which is the handshake, the change of cipher spec, which keeps us both secure and also not allowed to replay. So you can't replay this stuff. And then there's alert protocols, right? So the handshake protocol is used to negotiate the session parameters. The alert protocol is used to notify the other party of an error condition, right? And that's probably not going to be used very often, but it could be. Come down here. How do we do the shared secret negotiation, right? And some of you guys might know this, but the shared secret in a TLS communication is never shared over the communication. It's always generated on both sides and then used without ever passing over. And you can go read about that if you want. Secures against eavesdroppers. And then if you set it up properly, that's good. All right. Talk about all these things. Anti-replay, that's what I was talking about the anti-replay. Even if they capture, anti-replay is even if they capture everything and decrypt it, they still can't see what the message was. That's kind of an interesting thing. They always have, I do like when they have shall, should not, shall not. Those are things that are set in stone. When you say shall and shall not, you have to do that. Should and should not are, well, they're a little bit iffy, right? That's true of all protocols when you read them. Server keys and certificates, so they talk a little bit about this and how some of this stuff works. All right. Do they have anything else good in here? That's just a bunch of features and certificate revocation list where you can go and look to see if the certificate's still trusted by the certificate authority. And then there's the server public key certificate assurance. All right, these are all things that are built in and things that I think people should read about, but not necessarily required for the course, right? Do they have... We don't need renegotiation because we're on 1.3. Server name indication should always be there. Extended master secret. Synchronize 2 so that they share the same secret? No. Signature algorithms must use a certain protocol. And then can we revoke the status? Okay. So for us, the main thing for TLS operations are going to be those three most important things that we care about are here in the three sub protocols. So there's a session connection of the handshake, this change cipher spec, and the alert protocols. And they talk about that there. All right. So let's see. TLS operations will do that. We're pretty good on this. We need to figure out how I want to word our TLS operations stuff. Do I want to go into some of that technical stuff, or do I just mention for more information this? That's how you review more, right? And then if we a little little smaller so they fit. There we go. And we'll figure out how we want to work on that part. All right. In the course, then, we had the worksheet that I put together yesterday. The worksheet has some of the things that you're going to go and read about or dig into. There's the security service section of this doc, and it deals with system security. And then there's the TLS overview, which is actually the same one that we're looking at right there. 52R2. Yep, same one right there. And then how does TLS apply each of those things? So I have you guys look at that a few different ways in the course, right? During lecture term. Okay, this is all up in the Discord if anybody wants that. Now let's go look at the labs. We did the labs last night. Certificates and keys. And then also the SSH public and private key pairs and how that kind of works. Okay, so we got that. I think that part's pretty well set up. Let's see if I know the guys were putting Unit 9 together earlier, so they might have some of this stuff up there already, so that's good. Here's the lab. Okay. Then we got to do Unit 10, which Unit 10 is going to be the final, not the final countdown. The 24, yeah. So within any government spec, would any of the other protocols ever be used via TLS, such as TLS and Quick? I've never seen any of those standards required. I've never used any of those, so I don't know. I never used them. Never even seen them. Never used them. Definitely not doing that. Come on. DTLS, I see. I've not used that. But that's... I'm interested because that's interesting. And then there's Quick by Google. Yeah, I've never even looked at that for that. TLS and DTLS. I'm very curious about this one because I mean if you're doing voice over IP, you're doing that over UDP, right? So then you're not establishing a session. So verifying that has to be done each time, right? So that seems like that would be a lot of overhead. Seems like there'd be a lot of overhead. Yeah, see, he mentions these are for datagrams. So, yeah, well, I can just tell you, like, for government stuff, that's a non-starter. That's probably why I've never used these. Because, yeah, once you mention... So, guys, you know, TLS operates on transport, right? Or TCP as opposed to UDP. And whenever you're talking about datagrams, you're talking about UDP. And that's not... I'm interested to see what these models are, but I haven't ever worked with those. Because they're not going to... I'm very interested to see. I've never messed with this. Who's this from? All right. Yeah, I got out of networking full time years ago, so yeah, let's go look a little bit. Guys, by the way, if you ever struggle falling asleep at night, 1, put your phone down like an hour before you go to bed. 2, read RFCs. RFCs will put you to sleep. But anyways, let's go look. But they are the engineering diagrams and engineering ways that things work. So we know TLS is transport layer security, operates at layer 4. They're saying all those things. Then they're talking about SIP and all this voice over IP is always using datagrams. We know that it's all UDP. But now they're talking about a way to secure that from TLS 1.1. I'm very interested in what this is doing because it can't establish a connection. Each one has to be secured on its own. So, yeah, that's 100% true. Yeah, 100% true. Okay. Those are all known. Okay. So it's based on a timeout. That's interesting. Packet loss on a timeout. You got to reorder. You got to be able to reorder. By the way, if in voice over IP, if any datagram ever arrives more than 1/6 of a second late, it's just thrown out because your brain wouldn't be able to process it anyways. 1/6 of a second is a long time for a human ear. That's a long time for us. If I started like stuttering and changing, and if I had something that was like reordering my voice coming out, you guys wouldn't understand me for a second. It would be impossible. So, anyways, that's interesting. But are they doing it each time? They use an IPsec with authentication headers. Okay. They should have the field. They should have the fields identified here shortly. So they give us this, but they should show us what all the fields are, typically in a table. It's interesting. So you have to have smaller because it has to fit. So it would be better if you had larger maximum transmission units, but you guys know that the Ethernet 2 default is 1500 bytes. So they want it to stay within the same so they don't want IP packets to be able to be split, what we call fragmented into multiple frames at layer 2. So, okay, that makes sense. That's very interesting that somebody did this to solve this. Got different types of ciphers. Okay. That's good. I'm still looking for, this is all good, but where's the, okay, here's the actual exchange now. Where's the headers though? The handshake message format. Interesting. Yeah, I don't know. I don't mess with this for sure. And if I was more involved with networking, I would probably want to spend some time with it. But it's interesting. Timer values. Where's this? Guess they started introducing this pretty early on. All right. Yeah, it's interesting. Nick, Network Plus is okay. Yeah. I'm just reading about this. Okay. So let's we'll ignore that for now. We've got the certs. If anybody wants those, they just got to work for them. Nick, I probably missed some of your stuff, but yeah, messages are protected. That's funny. Yeah, the 24. It looks. I mean, it's just datagram TLS, but I still don't. I didn't see in there. I'd have to go read it a little more deeply, but I didn't see how they were. I saw the handshake occurring. I saw that part that they were talking about, but I didn't see how they were passing the individual messages in an encrypted fashion because there's no acknowledgement and window like there is in TLS. You just shotgun stuff over. So I don't know how they do that. You said what certs are good for Linux admin and security? I don't have, so I tell you guys all the time, I don't have any certs in Linux. I just have always done Linux. If somebody were to ask me certifications that I thought were kind of good to get in the industry, none of my certs got me jobs anywhere that I know of, right? I don't think so. But I think that the ones that I have them kind of ordered in the way that I think that they're useful. I think CISSP is one of those just like flagship ones that people want to see if you're going to call yourself a security person. I don't really, I mean, CISSP, like I see this all the time. Like they want a CISSP, but they are hiring somebody that's like a firewall engineer. And it's like those two things don't coincide. There's no firewall stuff on there besides knowing what a firewall type is. Like, so anyways, where I'm going with that is to say about certs, the thing I would do as in a resume like this, if I had nothing on my resume, I would work to start building out what I could show people about how I know how to do this stuff. So I would work to say like, hey, in my home lab, I've done this. I would have the bullet points kind of like, one of the things I'm always showing you guys is this right here. Hold on. Is like in our courses, these are the things that I think you put on a resume right here. These are the course objectives. These are the things that I think you should be able to say you know how to do when you're done with a course. Not just, I tell my college students all the time, your terminal course objectives are like my contract with you for like what you're doing. And these are the things that I would want to be able to put on a resume. I understand identity and access management frameworks. I understand how to tie my system into an LDAP because we built LDAP in that part of the lab right there. We built all that. So projects on GitHub are probably fine. I have stuff on GitHub, but it's not really like, I wouldn't necessarily like show it to anybody. I'd have it on my resume, but I wouldn't really expect anybody to go look at it because that's not necessarily what I do. But yeah, you could put projects up there. I mean, anything that shows that you do this stuff, and understand what the purpose of being a Linux engineer is, or Linux admin is. That's what I would work for. Completing these courses, I think, could be that positive differentiator for people. Other ones that I think would be valuable is, building stuff out, drawing out your understanding about things. I always shared a portfolio, Nick. I always showed people stuff that I had written and stuff that I had done. Yes, 100%. I've been doing that since the early 2000s. Yep. I always had like all my like whatever. I used to carry like a little binder, and then I would have extra copies of things to show people. Yeah. So if they were like, hey, do you understand how Perl works or something? I'd go, yeah, I definitely wrote Perl. Here's some of my scripts that I've done. But then for me, it was mainly that somebody could ask me something about like what my troubleshooting methodology was, and I could explain that. Because when we look at the jobs, guys, the jobs always have. Let's go look at an example over here. So let's go look over here. I know I have them up here. These were job skills that we had found, right? We went and found a bunch of jobs, and then we actually went off of the actual job board requirements, and we just started One of the requirements was install, configure, and maintain Linux operating systems. Well, can I even talk about that? Is it like obvious when we talk in an interview and you say, hey, Scott, all right, tell us a little bit about installing, configuring, and maintaining Linux operating systems. If I'm like, well, I know that like I have a CD and then the CD goes in the little compy thing on the ground and then I push the buttons and hit next, 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 and it builds a Linux box for me. They're probably going to go put you on the Windows team if they even do hire you. But because that's what Windows guys do. Next, next, next. Right. Anyway, so where I'm going with that is, so install, configure, and maintain Linux operating systems. What do I think you need to know about that, right? For installing, you're going to, and they were talking about software applications. So here's installing software on your system and updating it. And then maybe like, what's the build process for me for building a system? Well, one of the first things I would do is gather requirements, right? So for me, by the way, this is much more of an engineering thing when you start to talk about requirements. Admins are really just keeping stuff running most of the time, right? Inspector, you said, is there a resume that's known to work at Zorro yet? I don't know. Jared got over there. Jared's the one that's doing those interviews, so Jared's the guy to talk to about that. I don't think there's like a specific resume that's going to work for you on that kind of stuff. The 24 the last 10 jobs that I've went for were because people brought me over because they knew me. Yeah. And I think that's one of the best things I think that you can do. Bowman said Red Hat is enterprise and CentOS is legacy. Yeah, CentOS doesn't exist anymore. You would probably put on, instead of CentOS there, it would be either Alma Linux or Rocky Linux. And I have been mostly recommending people do Rocky Linux. And mostly because I have been putting Rocky Linux on like well over 10,000 Linux or 10,000 government machines that are Linux based in the last year. I've built more than 10,000 systems as part of bigger clusters, but more than 10,000 systems now that are just Rocky Linux. And it's a mix of Rocky 8, 10 and 9.4 or 9.6. I think are they on 9.6 yet? 9.4 for sure. So yeah. So build process and then early decisions. How are we going to build things? What's our cluster manager? How are we going to inventory nodes? Are we going to let a cluster manager do it? Are we going to do that with an IP address management, IPAM type solution? There's all kinds of things. There's all kinds of things that we might want to know. Win 10 replacement Linux suggestion for basic users, not servers. So ISO, then how are we getting, do we have an ISO and a virtual drive with iDRAC or IPMI, or are we net booting machines off of a working image? So like in my home lab, I have different ways that I can boot a system. By the way, this is also very important that you understand that you have to have another way to connect to servers. So I come here and I go to this AWX server and I've got the console here and I can drop, oh, wait a minute. This guy doesn't have to, we got to repair some stuff. Something's happened in my environment here. Let's see, are some of these still busted? No, lab storage is good. Okay, so we'll go up to the top here again. Go to AWX server. And now we can go connect any of the ISOs that exist in my environment. These are all ISOs that exist on one of my Linux boxes that are shared out as NFS. In fact, I can show you the box right here. Let's go. ISOs. Here are my ISOs, and they all correspond to what you see over here as ISOs that are usable in my system. So the reason I show you guys that is how am I going to load up software onto a system? I've got a bunch of servers out there, and this isn't super efficient. Taking an ISO and putting an ISO in each machine and going through all of your build every time, that's not super efficient. So what we do in the environments typically is we make a decision to use like a cluster manager to do a kickstart file. Kickstart file is going to, when a server comes up, it's going to go read its kickstart and it's going to install itself. Now in that, Nick said, Mr. Tanis, if you don't mind me asking, how much RAM are you pushing? In my home environment, I will show you exactly how much RAM I'm using. Hold on. I have a talk that I did a while back. It was like a group thing that we were doing. I probably should start doing this again. But it was our... Hold on. Gotta find it. I think it was prologue. It was like a meeting thing. Hold on a second. I know I definitely have it in here somewhere, but I just don't know where I put it. Thought I called it like prologue meeting, but I don't see it. So hold on. No idea where I put it. But I could have sworn it was right here somewhere. Well, I could have given you an exact number, but I can't find it. You know what? Hold on. It's over here. It's definitely over here in presentations. I definitely put it over here. Or meeting notes? I don't know where I put it, guys. Oh, that's memes and jokes. We hold on. We don't want to hang out there too much. We'll get kicked off the internet over there. Meeting notes. Hold on. I thought it was up in meeting notes somewhere. I guess I can just let you add it up. It's this box has 128 gigs of RAM. This box has 128 gigs of RAM. This box has 128 gigs of RAM. That's 3 something, high 300s, and then this box has 32, and this one has 128. So I think it's like almost 400, right around 400 gigs of RAM. You're talking like total cluster, yeah, close to 400 or so. Yeah, 128, 128, 128, and then 32. So a little over 400, maybe like 412 something, somewhere in there. My home device, my laptop here is 64 gigs of RAM. But I don't do anything on here on my machine that is virtualization or any of that kind of stuff. This machine is just for me to do productivity on. Everything that I do that's Linux based and all my work stuff is here and further out in the government or the cloud or wherever I'm at. So, yeah. Oh yeah, and my individual nodes, they have smaller versions of that carved up. So like this is a 128 gig box, but here's what all the boxes are using on top of it. Right? So here's all of them inside of there and how much usage they have at 4 gigs. And then this guy, his memory is he's the 32 gig box, but he doesn't have as much being used on there. And then this one is, only using 100 gigs of his 128. And then this one, I think this one's being the most wrecked. Yeah, because he's got the big Llama box on there that you guys can actually ask questions, and then Llama will go and churn through them and answer stuff for you guys and stuff if you want. If I was using Cube's OS, a type of hypervisor would be 64. I've never used it. Don't even know what it is. And then for efficiency over ISOs, you use Kubernetes for deployment. No, so I use so in my home lab, I use a tool over here called Werewolf. And this is probably the thing I deploy the most in the government space right now. And if I do tail-f on like varlog, Werewolf, we can see everything that's happening. But if I were to take like any one of my nodes right here, let's just say Hammer 7. And Hammer 7 probably didn't have anybody on it. Let's go check real quick. Yeah, he's been up 34 days. Nobody's on him. We're just going to kick him over. we're going to kick that box over for Hammer 7. And what's going to happen is that machine's going to come up. He's a stateless node. So when he comes up, he's going to ask the network, can you tell me who I am? It's going to ask over the DHCP protocol. And the device that's going to respond is the Rocky server, or the Werewolf server. And the Werewolf server is going to say, yeah, I can help you out, buddy. And by the way, because of your MAC address, I know that you are Rocky, or you're Hammer 7. And I know that you want to download this little iPixie and start up your boot process. So that's actually what's going to happen in this right window right here. Is he's going to come up, he's going to pull down his information, he's going to see that he's Hammer 7, he's going to download his kernel and his initram FS, and he's going to start himself up, and he's going to be that exact same node in under 180 seconds, so about 3 minutes. He'll come up and he'll be that exact same node again. So that's the way that a lot of the stuff that I build now works, is one centralized place keeps the containerized images, and then we can push that to multiple nodes and do a bunch of different work and kind of that stuff like that. So fix it. Your little Proxmox has 16 gigs. You do everything you need on 16 gigs, man. You don't need all that extra stuff that I have. I do have that stuff because I like to mess around and do just bullshit in my network and stuff, right? You guys don't need nearly as much stuff as what I've got going on. And most of the stuff that I have going are for these, the Rocky and Hammer servers, so that you guys can get in there and do the labs and do the work with me and stuff. So it's just more compute capacity for us, right? A place to go and practice Linux and then just, you know, reset things and start again and learn more Linux. Do these things until we understand them, right? So. Okay. Bowman said, wouldn't 3 minutes be slower than core boot? 3 minutes is probably slower than just like so, all right, again, this goes back to like what do you need in your requirements? So when we were over here, if we were talking about this, yes, there are faster ways to boot a system. However, this system just came back completely clean back to the original image, even if somebody had installed a web server on there, and even if somebody had broken. So if I had to like rapidly deploy things quickly, and I was trying to find, like, maybe let's say I was trying to find a solution to bzip being a problem. Bzip is a tool that, well, it's mostly gone, gzip, let's say. And maybe I had to go on my system and rapidly figure out. And every time I did something with DNF or whatever, it broke the system, and I just had to reboot and rebuild it. Well, I could be taking snapshots of virtual machines, I guess. That would be one way to do that. And on a physical machine, I could be rebuilding it bare metal, but that could take, you know, maybe hours if there's a lot of stuff. But this is a pretty fast way to just get a clean stateless node back up. And stateless, I always think of stateless like a little trapdoor. If you step on a trapdoor and then the trapdoor falls, it comes up without you on it. So it's like one of those little cartoons where somebody's like sitting there and they're on a trapdoor and then it falls and it comes back up. And a stateless node is always back to the exact original image of whatever you were trying to do. And it ends up being a pretty convenient way to run things, because then if I need to add new hardware, if I need to add, you know, new systems to this, I can just define new nodes right here. And I can have new Hammer or new Rocky nodes. I can set them to just automatically, or I can, so let's do node list dash a Rocky 3, let's say. And now, based on the hardware addresses, which I can either pre-populate as I generate these, there's commands to do all that, or I can have them come up and grab them as they go. Those pieces of hardware that I've put in the rack now can become real images. Now, I'm using virtual machines to simulate that real hardware. But out in like clusters out in the world, we have just racks and racks of compute nodes. And those compute nodes are checking into one server and doing the same process and just building themselves up pretty quickly. So, and then the provision networks tend to be like 10 gig networks, so they're pretty fast. And then the back-end storage networks tend to be like, you know, the back-end storage networks can be 200, 400 gig per second networks, so they're pretty fast. So. I got a question about why I use screen over tmux. I've just used screen forever. I don't have any preference. Some government systems that I use have tmux all over the place, so I'll use it where I need to. But yeah, in my home lab, I've always preferred screen. It's just the one that I originally used, so I use it. If I had started with tmux, I'd probably still be using tmux. You guys will find that I'm 100% like an old dog that just, if I've got a way that works, I'm like, that works, and I just stick with it forever. So 99 MRX said, do I like net plan or rather if up, down? I would say given my history of my career, I'd probably say I've used if up a lot more. If up and if down, probably way more than net plan. I've never really used net plan professionally. I've only ever used it in the lab, and that's only been on Ubuntu systems. That being said, if I can configure it out here and then let the container just come up, I'll do that too. So if the container can just come up with the defined information, that's fine for me too. They're always going to ask you about maintaining the Linux operating system. They're going to always ask you about monitoring system performance and troubleshooting. Always. They're always going to ask you that kind of stuff. So we got a bunch of stuff on, how do we monitor systems? How do we track the big four, which are CPU, memory, disk, and network? And then they talk about implement and maintain some security measures. These are real jobs. These came from real jobs that were out there, right? And then I was just writing stuff out that I had kind of thought about these different things. How would we monitor and maintain security measures? And then that was a big part of what this course was about that we just did. Manage user accounts, permissions, and file systems on Linux. So do you know how Etsy password works? Do you understand how you trust something else in your system to provide you with users, and how you might check that and set that up? That's was that unit 4 of this? No, it was user 3 of this. User access and system integration. Yep. All right, and then where else? I don't know what was happening here. Oh, that was my old. You guys wanted to see a resume. What does it say? System, RAM, processes. Professor, is it a stateless node you do projects or work on as required to do? You just keep those in storage? Yeah, so you always have attached storage. So on one of these nodes, right? So Hammer 7 should be up and clean, right? All of his stuff is in just as all tempfs, which is just RAM disk, right? This is all this memory here is in RAM. Goes away, it's volatile when the system boots. But these ones, all of these are mounted NFS shares, right? And here's all my NFS shares. So as long as I'm putting stuff in either home or opt or lab work or labs, then it'll always go back over there. Do I have... yeah. Frustrating. Very frustrating. All right, manage user accounts, permissions, and file systems. And then over here, perform routine system backups and disaster recovery procedures. So they just probably want you to be able to talk to the fact that you've maybe done some backups. You understand how backups work. You understand the criticality of them and say, hey, I could write a little script that could back things up, sync or rsync or SCP. Those are scripts that you might write, or you may have agents or tools that are being used. And then your job would be maybe to make sure that all the agents are running every night so that all the backups happened. And then maybe you automate something that alerts out to like Slack or Discord that all the 27 expected backups happened last night. Or maybe it never does that and only alerts if less than 27 occur. That's a very common way to do that kind of stuff, right? Install and configure server hardware and peripherals. They just want to make sure that you understand how to, if they've got physical machines, you can go in the data center. You can do LSPCI and LSUSB to see what's connected. If you take a machine down and you add hardware to it, can you go and validate that hardware was added correctly? And I always use the example, this is a very common example in my career. You'd go and you'd add like a PCI card to 10 different machines. 10 different machines get 10 different PCI cards. You plug them all in, you slide them back in the rack, you do whatever. You don't like lock them back in the rack yet because you might be opening them up. And 9 of them come up with no problem, but then the 10th one has something wrong. Well, you need to be able to go back to that box, power it down, pull it out, reseat that card, or maybe move that card somewhere else, and then validate on the Linux side that that card is in there, right? You say, what can those cards be? Those cards can be hardware bus adapters. They can be any kind of PCI slotted card. They can be direct attached storage card. There's all kinds of cards that can go into systems, right? And you say, well, what are they all? I don't even know. I could probably go in a data center and look at something. I actually did this the other day. There was a console server from Cisco that was sitting in one of our racks, but it was a customer rack that was in this data center that I maintain. And there was a cable coming out of the front of that I had never seen before in my life. I was like, what the hell is that? And then I traced all the cables. There were 8 cables coming out of this one thing, and they were all console cables. And I was like, oh, that's kind of an interesting. Never seen like a flat connector like that on the outside of a system. Almost looked like an old IDE connector, if you guys know what the long IDE connectors are. And just on the outside of a Cisco box. And I'm like, what the hell is that? And then it went to 8 different console devices, so then you could console in or whatever. Yeah, Proxmox is kind of like, so Proxmox kind of is a hypervisor. It's a type 1 type hypervisor where you can just stand up and build your own stuff. I use XCP-ng, but this really isn't supported much anymore. I don't even think this is getting really updated anymore. So I do advise people to go to more of a Proxmox model if they're asking for it. Can you collaborate with other IT professionals to plan, implement system upgrades and migrations? Well, yeah, you got to understand collaboration. So maybe you need to know some ITIL. It's a common framework for how we work with each other in the tech world. Maybe you learn TOGAF, which is the architect framework. Maybe you study some Agile a little bit and can talk about Kanban and maybe some sprint methodology. Doesn't mean you need to be an expert in it, but you need to be able to prove that you can do these things that they want. And they're going to be doing, there's a bunch of different types of questions. I used to have, in our server, I used to have little study groups where we would sit down and do these interview questions, right? And my interview questions come in 4 categories. They're technical things. I can ask you technical things, and then you can say, oh, I know how to do that, or I don't. Then there's troubleshooting things, which, oh, I know what I would troubleshoot or think through or whatever. There's operational things, which is dealing with like operations in the system and maybe how systems work and like tickets that come in and that kind of stuff, like how work comes in as an admin. And then there's personality questions, just how do you deal with conflict and how do you work in a team and those kind of things. So, all right, there you go right there. All right. So anyways, there's all those things. All right, man, I hear Ranger downstairs coughing. My dog is getting old. I can hear him coughing down there. All right. What else we have? We hit 2 hours, so that's a decent amount of time to stream. We're only at 4:30. I do got to find food here soon. Here's what we'll do. If anybody wants to keep hanging out, guys, we've always got a Discord. I'll link the Discord for anybody that wants it. And actually, what I might do... Let's not drop just yet. There's the Discord link. There is one thing I still need to do, and that is, this was me just showing you guys some stuff, and that was me showing you guys some stuff, and there was that. Let me go see if I have something else. All right, so I have a couple of things I still need to do in updating for the book. So maybe I'll take a little break and then I'll come back and we'll do some labs. So if anybody wants to do some labs with me, I'll get that stuff going. Let me pull this up here. Where's this? Because I do want to get a version of the book updated in the LeanPub book. So we have a book that is available on LeanPub, and it goes through all the labs, and it gives just a little bit more. Just gives you guys a little bit more stuff than we normally do in the labs or in some of the other discussions. So let me pull up this. Go to Killer Coda, and we're gonna dig into some of these other labs. So I'll go find the actual labs real quick. Where did I put this one? Did I put this in Kubernetes labs? Let's see. Nope. I put it over here in Linux. That'll be perfect. And it'll be 108, so it'll be Kafka to Loki logging. And so I think it's right here after those ones. Yeah, Kafka to Loki. So we'll do this lab next, and then we'll work on some stuff. Yeah, fix it. Thanks for coming by, even though that was probably a while ago, so I probably missed some stuff. Fallen, thanks for the follow. Hopefully the stuff's useful to you. We're going to take a little break here. I'll leave all this stuff up here spinning in case anybody wants to look at it. We'll get rid of that. And maybe we'll put Ranger up. How's Ranger doing? Ranger's laying around. All right, we'll do all that stuff. I will turn off my camera. And I will put up my little hourglass. And we will say, take a break. Let's go, take 10 minutes. All right, take a break and then labs. So if you guys want to come and do some labs with me, that's what we'll do next. back. Got more water bottles. Let's get going. Well, we'll wait to get going for the end of the break. We want to give people time to get back. You know, I do the same thing with my college students. Like I'll want to go and I'll be like, well, I gotta wait. I gotta be polite. I said that there was going to be this break and we're going to take the break, and then let's get this next part. Let's at least get this set up and ready. So we'll do task condition reflection. We'll do the Kafka Loki part next. That's good. We'll write these. We'll fix these as we go. All right. And then we'll get into our lab. So we got a little bit of time. If anybody's got any questions or want to know anything about what's going on, I'll try to answer them as best I can. Or at least point you to where things are. Oh, Bowman, I missed some of your questions. Sorry. You said anything. You said another thing, Professor. When I see enterprises, they still use Windows on the employee system, and all the Linux is run via VMs. Is this because of the friendliness of it, or is Microsoft that has to? It's more. So yeah. So you've got. There's a couple of things. Typically, you've got like your productivity machines, which are for like the human interface, and then there's like your back-end systems that are like your highly available production type systems for people. And I would say that those systems, I always prefer those to be on Linux. But stuff that's going on like how you get into Linux, I've never cared about. Like as a systems engineer, if you give me a terminal on a Windows box, that's fine. If you give me a Mac, I don't know how to button click on Mac, but I can type. So as long as I can get to a command shell. Nowadays on a Windows box, you can just open up a command prompt and do SSH. SSH is built in. So it's like, it's one of these things where like whatever the productivity tool that you're using is, I don't think it matters as long as you get in there. Yeah, you can do all the Linux. Desktop Linux is perfectly fine, but I would try to find an organization that's running that standard in the organization. And if you tell me Red Hat, I can guarantee right now Red Hat's not running Red Hat on their desktops. I know that because I work with their engineers all the time. They run all kinds of versions of Fedora, and they're all running them themselves. So it's like, I don't know. I mean, I don't know. I don't even know how they're managing security over there when everybody's just building their own laptops. But that further proves my point of it doesn't matter how you get into a system. Because once you get into the actual Linux system, that's when you start, doing everything you need to do. So, okay. Let's get to the Kafka and Loki logging part. We'll give it one more minute for people to show up, and then we'll go. Go here. Pull this up. Move it over here. And this is going to be, given Linux system, right? Deploy Kafka, and then send messages to Loki. Okay? Loki. Execute commands, understand the output of the given system. Good. Reflection questions. All right, so now we'll make this a little bigger so we can read everything. Right here. And we'll do our lab. All right. So, we'll make this bigger so people can read what I'm doing. And, here's the lab. If anybody wants to do the lab with me, here it is. Boom. So this is going to be our deployment of Kubernetes Kafka. Also, they started this a while back for you guys that are on the Twitch side of things. YouTube side, I know that this won't, I don't even know if there's anything on YouTube that's similar to this. But on the Twitch side, they now show who does the most clips. So, I don't know. Anyways, the reason I point that out is if anybody wants to, if anything I say or anything that I build or show you guys is useful and you want to clip it, please do, because then I get a copy of that. And the reason I say that is because I can't tell you guys what's interesting to you. Only you can do that, right? So if you do ever find anything that's kind of interesting, do that. And I'm gonna have some kind of bounty up in the Discord for the people that do that the most. I don't know what that's gonna look like, but yeah, we'll do something. I typically I just tell people to pick a humble bundle that they think looks interesting, and then we get that for them. But all right, so your team is going to be integrating an Apache Kafka message bus with existing infrastructure. So you've got something already built in your company, which is Loki. In fact, here's the drawing. Let's go look at the drawing. And I right click and I just say open in a new tab, and it'll pop up in a new tab inside of Chrome. And here's what we're going to do. We're going to have some existing company infrastructure. Now, does it make sense that for this lab nothing's existing? You have to build this out. But we'll just go ahead and pretend that this is built out. Cool. And then we're going to have these two nodes, so control plane and then any node, could be any node in our cluster, is going to, control plane is going to send messages up into Kafka, and any node in our cluster is going to pull messages out of Kafka and send that in over to Loki. So that's our architecture. That's what we're building. Sometimes it helps to kind of look at the stuff and visualize what am I doing? Where is the traffic going? It depends, people would call some things northbound, some things east-west, and then it just depends on where the traffic's moving as far as that goes, right? And there's different definitions for that stuff. But for now, that looks like a pretty good little drawing of what we're going to build. Okay, so I come back over here. Your team's determined that they need to offload and monitor Linux logs in your environment, and we're going to build Grafana and deploy that for that first part. So we'll press some buttons here and get the dependencies in place for Grafana to work on our system. So I'm just hitting some buttons here. This actually comes from a different lab too. Oh, damn sudo's still there. All right. Install this next part. And then we're going to download this keyring. Right, download the keyring, throw it in a keyring location. Then we're going to take that keyring name and throw that, say signed by that keyring and app Grafana, and throw that into apt sources list.d grafana.list. So we've made a Grafana source that our system's going to trust according to that key to download software packages to the system. These two first commands were just against software packages in repositories that were already trusted, right? Now we're downloading and giving trust to Grafana via these keys that now we can go download. We're going to update all the metadata information, and then we're going to install Grafana Enterprise right here. So, Veer, you said you were looking for some career advice. My company recently made us redundant in a restructure. I'm a bit of a late starter in IT with 2 years as sysadmin. 35 now, want to explore IT domains for a solid, well-paid career. Any honest suggestions or tough love appreciated? Cheers. Well, Veer, I would tell you one thing I noticed very early on, getting into IT I was in my early 20s, is that you're always going to have to learn. So you have to keep building and understanding these things as you go. So I would tell you, make sure you keep learning something. How you go about learning that stuff is going to be up to you, but I would hope that you're involved with some type of group, right? I hope that you're involved with some group of professionals that are doing this stuff, and then maybe find a challenge or a cert. A lot of our guys. Can I show you something real quick, Veer? I'm gonna go to an aside real quick. For you guys that haven't been around or newer, and Veer, I think you've been around a little bit, but you might not have seen this. Did you know that we have all these free certs out here that you can go get? That they're not our certs. These are just certs that the industry has, and I try to keep this list as comprehensive as possible. So if anybody else knows of any certs, the API Academy has free training out there, and we've got a little study guide for you to help you get through those tests. And then you would get there's 3 certifications with that, and when you're all done, there's an API designer, like these little PDFs that you get, and they just kind of look nice, and they're nice to be able to throw in a portfolio and say, hey, I'm not really an API engineer, but I understand APIs because I have to hit APIs all the time. And I tell you guys, I'm a platform engineer, and I do API stuff all the time. So that's one. Chaos engineering. You want to go do site reliability engineering? There's a free cert from Gremlin that's out there that you can go do. I've got it probably I don't know, if I had to guess 30 or 40 people in our Discord have it. And the last person that took it, he just spent a couple of hours on it and passed it. So that's free. There's free Six Sigma White Belt and Lean Six Sigma White Belt certs over here at Six Sigma Council. And free's a good price. All the material to study that is also free, which is also a pretty good price. And then look at this. You go have that and you say, well, what's a Six Sigma white belt and what's a Lean Six Sigma white belt? It's just generic engineering. It's process improvement engineering. And you could, Six Sigma white belts, I mean, I think process improvement engineering is great. Like Six Sigma type engineering has been great for me in my career. I don't even mention it to anybody. I don't even mention, like, when we're talking with other engineers and I'm working on stuff and they're like, how'd you get that? I'm like, oh, that's just a histogram of buckets of all the dates and the things and kind of, I was just looking for another way to look at the data. And they're like, that's really interesting. I learned all this stuff in Six Sigma. Well, in college, but in Six Sigma, right? So this is like, especially when people tell me, like, I don't want to go to college, but I still want to be an engineer, like a proper engineer. I say, okay, fair enough. You've picked a hard road to hoe, some of you, but yeah, hard road to hoe. That's exactly right. Lean Six Sigma and Six Sigma will give you a lot of the skills to understand that stuff. Then there's IPv6, and I'm pretty sure Inspector's the one that's always selling this one. But these guys, they have a free certification for you to go say you know IPv6. So you go into a company and they ask you all this stuff, and they see that you've got this IPv6 certification on there, and you go, well, yeah, you know, I understand how to deploy it. I understand what a quad A record means for DNS. I've done some basic configurations in a lab with a company that does they do global networks, these guys, these HE guys. And then certified in cybersecurity. Last time I checked, the first 1 million haven't been all taken for this, so they're still free. So, yeah, here you go. So there's all the. So again, so to answer your question, hopefully, Veer, the best thing I think you can do is always be ready. Always be ready for that layoff. Always be ready to land somewhere. Always have your skills sharp, because you don't know. You don't know when you're going to have to prove again that you know how to do this stuff. So get some of those skills out there and kind of be ready for some of this stuff. That's my thoughts, right? Apple ecosystems, why aren't these as popular in college? Seem like college mentions CompTIA ISC squared, and then enterprise mentions GIAC. It depends, Bowman. I think as a longtime college professor, I think people that have managed to get into like the college space have figured out that colleges are going to deploy things that are easy and when I say easy, I mean easily consumable by their students, right? You got to understand, like when I have a group of students, I only have 8 weeks with my students, and typically the 8th week is just a review or like a final or something. So I only have 7 weeks effectively with my students, and maybe some influence for the end of that last 7th week or whatever. But my point in saying all that is, like, the things that I have to do with college students have to be easily digestible. The things I tell them to go read and the things that I ask them about in like a Socratic method, they have to understand, or they have to be things that can be consumed in the blocks of time that we have. Does that kind of make sense? I always think of, you guys are going to think this is silly, but I think of a college class as like the old game, the Oregon Trail. You got to get from Chicago to Oregon. You're going from east to west, going out west to get over there and get your plot of land or whatever. And you're bringing your family, and people are dying of dysentery and all this other stuff. And there's all these little side quests you can do. But then when you're done, you've got to get to Oregon. You've got to get to the end of the course. So you've got to go through all the components of the course, right? And by the way, that's all seen in, as you look at these courses that we run. These are the same exact types of things that I used to build at an old college that doesn't exist anymore, ITT Tech. But I used to build the syllabi just like this. Same type of thing. Okay, anyways, let's get to this because we only have 50 more minutes in the lab, right? So we've got Grafana running. We're going to do a daemon reload. We're going to start Grafana up, and then we're going to check the status. We will not see Grafana listening for about 10 seconds. It takes 10 seconds or so the first time it comes up. And when it's done, we're going to hit that, and there it is. Boom. All right, we come down here, and now I've got Grafana running, so I can go configure Grafana. So I'm going to hit this button. Go drop into my Grafana. Again, I hate all this stuff that's about to pop up. Admin, log in. Don't want any of this crap. Get out of here. We're gonna make the password something super secure, like 1 2 3 4 5 6 7 8. Right? Get in there. Don't want to save any of that. Now we've got Grafana up on that box. So we just built Grafana out, right? So change the default user and admin password and go to the next part. Now we're going to configure Loki and make sure it's listening on port 3000. So we're going to turn that on. We're going to make a directory. Opt tends to be where we put third-party applications or software. Agents tend to go in opt. So opt, we're going to cd over there. We're going to download and unzip Loki and make it executable. Then we're going to take our config that we already wrote beforehand, right? This config's already built for you. I don't make you go spend time trying to make the config. And then we copy in the service file and do a daemon reload. We look at the config. The basic Loki config says we're listening on port 3100. Cool. We're listening on the local host. And then there's some other stuff that you can go play with if you want. The one thing I always want to mention to you guys is I set reporting enabled to false because typically this is commented out and they have it as reporting enabled false like that. But then they tell you up here, we're going to send the data by default. Well, if that's a default, that should be set as the default there. But that's not true. They say, so reporting _ enabled : false should be pounded out on this, but it's not. So I think that's dishonest, and that's something that they do. And I call people out for stuff like that. Not to be a jerk, but just to show you, like, if you're doing this for your company and you have a very locked down security posture of we don't send stuff out of the company, you would have immediately installed this and started sending stuff out of your company for Loki right here. And I dislike that. And I dislike that it looks like, if you don't read it, it looks like that's the default setting, and it's not. It says right there, the default it will send. Anyway, so, all right. So we go and look at the system config. This is a very simple system config for how we're going to start in systemd that service. And look, it's just a call of the executable that we downloaded and that config file that we just looked at. That's all it is. That's the whole start of this service. So we enable it and start it, and then we go look and we see that it's running. Yep, we see Loki and we see 3100 listening. Boom. All of our Linuxy things are done for that part of the lab. All right. You might say, Scott, can't we go into that a little more? We've got a different lab that builds Loki. This lab is about the Kafka integration. So you're really just building right now. You're building this, which is the existing infrastructure, which is not what we call germane to this conversation. This is just extra, right? It's not the purpose of why we're here. Purpose of why we're here is this next part. So we'll do the promtail, and then we'll make promtail the same way. We're going to go copy things in. And then we're going to do a little thing here. So look, here's our scrape config. Syslog and authlog are the two default things that I put in here. They are not, by the way, the default things that come with this. If you go download the scrape configs for promtail, you'll get the Red Hat ones, which are varlog messages and varlog secure. Those are the two that'll be there. So I've already modified that from Ubuntu for you. We're going to do a daemon reload, and we're going to start it up. Whoops, we probably didn't copy it in. We're going to do a daemon reload, and then we're going to see that promtail is running. So cool. All the components are there. Grafana, Loki, promtail, everything's being sent like it should. So the existing infrastructure of our company that already was there now exists for the purposes of this lab. Let's go do the Kafka part now. So we come over here. We're going to check and move forward. Oh, we'll set up the Grafana piece first. So we'll go into our Grafana instance, and we're going to tie into everything. So we're going to come here and say connections. By the way, everything I'm showing you is right here, right? So connections, go create a data source. So connections, Loki, that's what we're using, right? So we're going to go Loki. We're going to add a new data source for Loki. It's going to be named Loki, and we're going to point it to 127.0.0.1 on port 3100. That was the port we used. That makes sense. We're not doing any of this stuff now. We're going to do this in a later lab. I'm going to have some TLS stuff in there, but that's fine right now. When we save and test, if everything's right, it'll tell us it's right. And I love that about Grafana. It always tests things for you. And then we say, okay, so we've got a data source. Let's go make a dashboard. And our making of a dashboard can be an import. And the import of the dashboard we want is this 13639. So I'm going to say import 13639. And we're going to load it. And then we're going to use that Loki data source. And we're going to import it. And here's our dashboard. And here is the auth and the syslog that were programmed down in promtail to send over to Loki. So things are already happening in our system, and there's already logs being sent over for both syslog and authlog on our system. That's pretty cool. That's all the things that we needed to start. So now the next thing we're going to do is we're going to integrate Kafka to that infrastructure. So we're going to go set up Kafka, send messages in, pull messages out with our promtail, and throw those messages up. Now real quick, I want to show you guys. There's only auth and syslog. Do you guys see those two things right there? That's all we have. All right, that's very important. Let's go build our Kafka stuff. And here's our answers file that has some answers. So we're going to create Kafka on our system. So that's just a namespace. So kubectl get ns. Here's all our namespaces. And 9 seconds ago, we created Kafka. There's nothing in it, right? And it should make sense that there's nothing in it because, well, we just made the namespace. So we check it and we see it's empty. Now we're going to create this file that we have here called in answers. So if we cat answers zookeeper, this is a config that I put together that's going to start up zookeeper and make a service for zookeeper and also a deployment of zookeeper from the default image for zookeeper. Okay, so we're just going to hit that button and create it. That's a thing that I configured beforehand, and I do say if you want to go read more about that, there's a different lab that builds all that and shows you how all that gets built, right? So then we go look in there, and here's all these things that were just built by our simple thing. We built a deployment. That made a replica set. The replica set desires a certain number of pods. Here's the pod. Then that pod is front-ended by a service called zookeeper-service that now has this set cluster IP. And if I go look at that, let's create our Kafka stuff. And then we'll go and look at that. And here is the description of Kafka. Here's the front end of its service. And its back-end endpoint, if we give it a few seconds, because the container's still creating, when that container gets a IP, now we're going to see that IP. Oh, it's not built yet. Give it a few more seconds. Let it churn a little bit, right? Typically, we're not setting things up in an industry. We're going to just be running things. But now there it is. There's the final 192.168.1.5, 192.168.1.5. That's our Kafka broker. Perfect. That is this component right here. The Kafka back-ended with zookeeper. It's just needed so that Kafka can work, right? Come down here a little bit. We're going to install Kafka cat. We're going to set up our port forwarding so that when we talk on our system, it automatically goes to the right port. That's not really super important to what we're doing here to know, but it is talked about in the other lab. And then I'm just going to make some messages. I'm going to say, this is my message at date. I'll wait a few seconds. Here's my message at date. And we're going to just send that in a few times. And then we're going to go read with that same kcat those 3 messages. There's our 3 messages that we just sent in. Cool. That's good. But now that we can send, now that we can send messages in and we can read them back out actually with the same node, let's go set up our prom tail to pull messages out of Kafka and send them over to Loki. So right here, I'm going to refresh this to show you guys that there's nothing up my sleeve. There's only auth and syslog. You guys see that, right? There's only auth and syslog. Those are the only 2 things that I can select right now. Come back over here. We're going to set up Apache Kafka, and now we're going to send in to a topic called system logs and send things up to Loki. So right here it says while true, let's just throw some things in and make a connection. Now it says run that loop over here and then open a new tab in the top. So here's our new tab. We're going to make this tab over here. We'll make it real big so you guys can read it. But just know over here, this thing is always looping with some random number and the date. That's all it's doing. It's just making a random number between 1 and 10, and then it's doing a random date. Okay. So we come back over here, and we are going to cd to opt. Whoops, not in there. Gosh. Over here, we're going to cd to opt prom tail. It's my fault. And we're going to vi that config. And we're going to shift G to the bottom, hit O, and we're going to make a new config. So look, we've got that syslog and the auth log, right? So syslog and auth are the 2 right here, syslog and auth. Boom. Now we're going to go make a new one, which is Kafka. And look at how Kafka is going to work on our system. It's going to use node 001. Did I? Oh, hope I followed my steps right. Hold on. I did not mean to turn that on. Node 31,000. I hope I threw everything where it was supposed to be. Here's the topics, the syslogs, and there's Kafka. All right. Yeah, there's our broker. All right. We're going to hit escape, :WQ. And when this works, so we're going to restart Promtail. And then we're going to refresh the page and verify that the app dropdown for Kafka now has 3 entries. Refresh, there's Kafka. And what's Kafka doing? It's writing, and I can say refresh every 10 seconds. So every 10 seconds, I would expect this to give me the next things. This should give me the next. So it's message 7 at that time, 11:29. There's 11:33, 11:36, and 11:39 right there. Those just popped up. Those are all new. So now we'll wait here with the 11:39 right there. And then now it's the next 3. Every 10 seconds, this is refreshing. But this is over here sending every, I don't know, whatever our time was. Every 3 seconds, this is sending a new message into Kafka. The message is being pulled out and passed all the way through via the process that we defined here. So control plane sending messages up to Kafka. Some node is pulling it out via a Promtail consumer to read those messages out, and then it's sending it up into our already existing low-key infrastructure inside of our organization to be chewed up and read and API called and whatever we want to do inside of that system right there. So Sinbleed said, are you working on SE Linux or AppArmor for Mac from user space for Linux security? We do a little bit of that in the security engineering course. We did that like kind of early on in the course. But no, in my home lab, I run SE Linux, but it's in a permissive mode. Just because SE Linux can kind of be a little bit of a nightmare sometimes. Yeah, but Sinbleed, I don't always use it. It depends. In government systems, I tend to have to turn on SE Linux, yes. Non-government customers, we tend not to have it on. I mean, at least from like a general security posture. We do all the other required Stigs and all the other things, but we tend to turn it off for that kind of stuff, especially down in the compute nodes. In the compute node section of things, we tend to turn it off. In the data entry, like so if we have data valet nodes or data mover nodes, we call them, or we have login nodes, or we have like web front end nodes, those nodes will often have SE Linux on because then it's just a little more secure, and that's the part that jumps past the bastion. That's the actual bastion connection into the system typically, those 3 types of nodes. And by the way, if anybody's ever looking for the definitions of those are all found over in NIST 800-223, which is down here, and then the definition of those nodes are in this drawing right here, which is a very common drawing that like my organization, we show this to customers often and say, this is what we build. This is like if you said, Scott, can you show me your whole career in high performance compute? It's in this drawing right here. And what I particularly specialize in is the Ansible that builds these and the cluster managers that run them, and then the automation that kind of makes everything the same. That's kind of what my career's been based on right here. Right. All right. At least the last many years of my career. All right. So we need to think about this. So our reflection questions would be, let's think about what we built, and then let's say, what are some reflection questions about this? Yeah, Sinbleed, yeah. I think SE Linux is it. The additional labeling is great, but then it's like, I always tell you guys, like, there's this idea of like security is the enemy of productivity. Security is great, right? Security is an awesome thing to do, but then we talk about, we've talked about this before, where if I know that there's 367 STIGs, the Security Technical Implementation Guidelines, for a RHEL 8 server, why doesn't every RHEL server just come out with all 360, something of those turned on? Why not? Well, the answer is nothing will work. So we always because there's all these requirements and all these security best practices, but when you do all the best practices, you also lock it down so narrow that other functions don't work. So where I'm going with that is we have to sometimes loosen certain types of security to allow productivity to still occur, because as I've often had to tell engineers that come into a company, like no company I've ever worked at is like trying to run 1,000 Linux servers just to be able to like check a box and say we run 1,000 Linux servers. I've never met a company that does that. I've never even met a company that runs 5 Linux servers just to be able to say they run 5 Linux servers. Every single Linux server I've ever seen a company spin up was for a reason, a business process, or to test something, to become a business process, or to, right? Like I don't understand the concept of like, we just have Linux servers to have them. Well, the reason I say that is because a lot of times when you're talking to engineers and at the OS level, they'll just be telling you, fuck it, why don't you turn them all on? And you're like, because it doesn't work. You'd be like, why doesn't everybody drive the same Chevy Camaro with the seat all the way up? And you're like, well, if you're over 5'11", you can't do that. You hit 5'11" and you can't fit in that car anymore. Also, I don't know if any of you are older than like your mid-20s. Sitting down into a car like that, like I thought when I was younger I wanted a Corvette. I don't want nothing to do with those things now. I like getting up into my truck, right? Like that's much more convenient than sitting down at like ground level, like basically doing a pistol squat into your car and sitting over. I don't want to do that shit. And like a pistol squat to stand back up. That's a young man's game. I could do like 2 of those a day. I'm not doing a whole bunch of those. This isn't a CrossFit gym, is it? Anyways, my point in saying all that, I don't mind CrossFit. It's just like that's not what my goal is on any of this. So I don't know where I was going with that, but anyways, the point is, yeah, security and productivity are at odds with each other often, and something has to give in a lot of these situations. So security and Linux, yeah, that's fair. That's a fair point. I think I do more with securing systems around immutable containers, no ability to escalate out of the process, like the Grafana process or the Promtail process or whatever, is its own user, and that user doesn't have any permissions. So even if you manage to compromise and get in on like Prometheus or something, you can't escalate any privileges because you're using a non-privileged user. Or if you compromise a container, it's immutable. You can't write anything to it, and you can't change the process in any way. So, okay, congratulations. It's like you're writing a Sharpie on a granite wall. You can't really do anything to it, right? So, anyways, all right. So let's look at the lab. Let's go back through the lab and say, okay, what did we do here that we want to ask about over here? So given a Linux system running Kubernetes, deploy Kafka, it's capital K, and then send messages to Loki. It's capital L in this case. All right, given a bash prompt. So reflection questions are, let's see. What reflection type questions might we do that are more specific to what we're setting up here? Look at the solution. Did all that. Trying to think, because the questions here none of this first part really matters because they're all answered in a different lab. So let's go a little further over and say, yeah, this goes pretty far, because then we get over to here. Let's go look at, whoops, we can stop this, and let's go look at get all Kafka. And when you finally got to the section on Kafka, why did you have to deploy Zookeeper first? So why did you have to deploy Zookeeper first? That's something to think about, right? And then maybe sub points to that. What is the port number that Zookeeper is listening on, and how would you maybe find that? Well, We would know that by looking at the Zookeeper service. So, if we, yeah, this is service Zookeeper right here. And that's the port that it's listening on, is 2181. And then the node port, the actual port that's going out, is 30,900. But the endpoint is listening on 2181, and that's what's being passed in from Kafka as well. So what is the port number Zookeeper's listening on? Okay, that's good. We don't have to get too deep in on that. Let's go here. What were the messages? Into Kafka. What were they comprised of? They were comprised of a random number and then a date. So they said, this is my message at some random number and then date, right? What is about the job name, or actually the job label that is applied in the Promtail log for Kafka? How does that map? How does that map to the dashboard in Grafana? And this one's a little trickier than other ones because this one's not super, like you've got app over here, and then app now has Kafka once it gets scraped. But look at this. This is something, and this is maybe something you'll have to dig in a little bit on the reflection questions. But if we say make this editable, and then we edit it, right? Let's go settings, and we go look at the variables. There's an app variable that reads the label into job. So see labels underscore values, that's actually getting pulled into this variable app. And then when we go back to the actual dashboard, we're not going to change anything. And then here's app, but it's actually showing that label, job label, that's coming through the system. So that's how that all maps over, right? And that's maybe not super intuitive, but you'd have to have played some time in Grafana to catch that the app is actually being mapped to something else. This app is the name of the variable in Grafana. It doesn't matter what the hell it was when it came in off of a scrape label, but that scrape label had to be mapped in some way, and it was done back in the page here under variables right here. Right? Label value, the label is job, and over here that's ls, and then right here there's the job name Kafka. So that gets mapped, job names gets mapped back to the app, and then there's the app right there, Kafka. So yep, it's all just chutes and ladders, right? 4 is going to be, do we have a fourth one that we want to know? Review what you built, and then the diagram. Does it make sense? Why this might be used. Okay. And then digging deeper for this one is going to be this, which is a completely different. This is telegraph to Kafka Wayfair, which is topic-based routing. No. Yeah. So digging deeper. Review this document a on page 14, while they are not using Loki Promtail, but rather Telegraph and Influx DB, how is this similar to what Kafka was doing in your environment? So, right here, if you guys are looking at this, they have Kafka as a system bus right here through their whole environment, Ireland, Boston, and Seattle. And then Telegraph is sending in messages from all these different nodes in a highly available, always ready to write Kafka cluster, right? And then over here, they're sending more in over here. Now over here, they're pulling it out with Telegraph. So Telegraph has the ability to pull. There's all kinds of tools that can read and write into Kafka. It's a very, very lucrative thing to get into, especially if you want to do app development. But now Kafka's pulling stuff out and being thrown over to InfluxDB. It's another way you can monitor it. It's actually the first time I ever saw Kafka used was in this type of situation right here. How does using Kafka as a system bus create a higher availability of your metrics or log collection? And I've seen it for both metrics and log collection, but that's a good one to kind of think about there. All right, so that's that next lab. Oh, and here's the, let's go grab the actual lab right here. So, in case you guys are wondering, this right here is these are my updates for like the book. The, let's call this file save. And then we'll just call this like, because I want to have a version of the book out again. Anybody that's ever bought the book, by the way, in case you guys are wondering, you always get all updates in perpetuity. Like any updates on LeanPub, you always get alerted to new publishes. So that's actually kind of a cool thing. Veer said, might ask additional questions. Yeah, you're always welcome, Veer. That's the whole purpose of this. This is why I hop on, is to tell you guys that we've got a Discord, that there's a place to go hang out and talk shop with other engineers. That's why I do this stuff. It's not to hear myself talk, guys. I tell you guys sometimes, actually, you guys might not think this is as funny as I do, but like anybody that kind of hangs out with me here, you're choosing to be here. My college students, they fucking have to listen to me. My junior engineers, they have to listen to me. You guys don't have to. You guys are just chilling. So, and by the way, you know what? I haven't done in a while because we've been focusing on these groups. While we were doing the group, so I did have some different engineers of mine come in and talk. But I do need to get back to, this is one of the things that I don't do as much when we're running the groups and I'm making them, is getting people to come and talk every month to the group. Typically, we've had our AWS architects, we've had some of our different systems engineers. We do have a really big event coming up, and I've got a bunch of guys coming to talk should be here. Should be at the end of August, or beginning of August. We're going to have, so Friday, August 8th, Saturday, August 9th, and Sunday, August 10th. We've got a bunch of different guest speakers coming to talk to you guys. And I think I have most of them already published out there. If you go to conferences, I think it's under conferences. I think this is where I put it when I was working on it. Yeah, this is kind of what it's looking like so far, although those dates and times aren't right. Those dates and times were a little wrong. We had a script issue. But I'll get those fixed. But I'm going to do a kickoff on why engineering. Tomodius, my brother Tom, he's actually a data analytics guy. He's walking for his master's on Sunday. So he's done with his master's degree. He does data analytics for a very big company. His project that he mostly runs, he runs a lot of stuff, but the main project he runs is worth about $150 million a year. So he's pretty good with data analytics. He comes in and just shows you guys all kinds of stuff in SQL and Power BI normally. Salty Catfish is one of our senior programmers. So is King Buns. They're both leads on their teams, and they've both been software engineers Salty's over 10 years. I think King Buns is kind of approaching 10 years, and he's a lead, so it doesn't really matter. I don't think once you're like a tech lead, I don't think it really matters how long you've been in the industry. Once you're like the guy in charge of the team, technically, I think all the other stuff kind of is like out the window. You were leading the team. You were the guy that everybody went to, right? Sending Grounds is going to come and talk. He's awesome. He does a whole bunch of AWS systems engineering stuff. And then Control Byte is going to come and talk about DevSecOps without the buzzwords. That's going to be funny. And then I still got to fill a couple of these, but I have an economist that's coming to talk, and I got to pick a time. I got to figure out time for him. And then I've had like 2 or 3 other people ask me for time slots, so it'll be kind of good. I think we're going to have some good time spots. Good. I think all these topics are excellent. I think everybody does good stuff. In fact, my base engineering talk from last year, I'm going to update it a whole bunch because I think that like it's not going to be, I mean, like there's no like winners or losers, but I am going to have like a little, like we're going to have like a little bit of a challenge because we did, last year we did surveys and people did surveys of which ones they liked the most. And I'm going to try to get it this year where maybe when everybody's all done, they do surveys of the ones they like the most, and then I'll do some kind of I'll do some kind of award ceremony or something, maybe on the last night or something. We'll figure something out that makes it fair. But I always do something for my guest speakers anyways, so they come in and get to talk to you guys. But all right, let's do more labs. So we did all that stuff. We did that one. The next lab we'll go do is 109, which is the fail to ban with log monitoring. So we're going to take fail to ban and we're going to send it into logging. So let's go see if we can find that lab. Also, you guys will notice my labs have been getting much more complex because I think that this stuff is valuable for you guys. So here's the lab if anybody wants to do it with me. And there we go. Yep. I'm going to go drop this up here. There's the lab that we're actually doing. I can make that little... you guys can still read. You guys can still read that, right? All right. So now we need to do this task condition standard for this lab. And given a system, Linux system's running, given Linux system, install and actually, hold on. How does this one start? I don't remember how this one starts. Yeah. Protect with fail to ban. All right, so protect it with fail to ban. And then, oops, well, of course my validation is going to fail. Tie it into Grafana. Okay, and then tie it into your monitoring solution. Condition will be given a bash prompt, complete in the allocated 60-minute time. That's always the condition. And then the standard is execute and understand commands, understand command output of the given system. I would say execute and understand commands, have a functioning fail to ban that is sending logs to Grafana. That's your standard for this, right? That's what is the win condition, right? If you want to think of it like that. And then reflection questions are not done yet. All right, let's go do it. So, first one, your team is testing fail to ban to protect the SSHD process of your server. You've decided to build a POC or a proof of concept of the system and tie it in with your Grafana monitoring solution. That's fair, right? That's what we're trying to do here. The solution down here is to install fail to ban. So let's do app-y install fail to ban. And it's going to install some dependencies that are needed for fail to ban to work properly. Now, if you've never used fail to ban, I'm going to tell you guys what it does, and then I'm going to ask you to think about what you think it is in the concept of a couple terms. Fail to ban is going to create jails for processes, and then if users keep attempting to log in or processes keep attempting to log in, they're going to get blocked out of your system forever. That's what fail to ban does. It bans things for time or forever or whatever you want. So there's two concepts that are very important to understand in systems engineering, especially around networks, and that is intrusion detection and then intrusion prevention. So intrusion detection systems and intrusion prevention systems are IDSs and IPSs respectively, right? That makes sense. IDS, IPS, whatever. An intrusion detection system simply watches. It only watches. Intrusion detection system is like that person behind the Nat Geo camera that watches the cheetah catch the little gazelle and eat it, right? They just sit there and watch, and you're like, you're a monster, but they're not a monster. That's their job. An intrusion prevention system stops things from happening. It does not just watch. It actually does something. So I want you to think as we're doing this, is this an intrusion detection system or an intrusion prevention system? And are we using it as both? Can a system be both? Because technically they can, I guess. But what is fail to ban? Is it intrusion detection? It just watches, or is it intrusion prevention? And it actually does something. So let's go and work with fail to ban and see if we can answer our question. What's the client version? 1.0.2. Perfect. And we're going to go in and look at the jail that exists. And this one gets people a little bit. So watch this if you haven't done it. We're going to enable SSHD right here. And then we're going to add these values down here. We're going to say max retry 5. And then if we need to, we can back this out. Right? And pull that down. And then I'm going to hit shift. Actually, I'm going to do / SSHD. And go look for where it's down here trying to be sneaky. And we're going to delete this down here. Now, some of you might say, oh, shoot, hold on. Didn't mean to put that up again. Now, some of you might say, well, hold on a second, Scott. Couldn't I have just put it down there? Yeah, you could have. You could put it wherever you want as long as there's only one. This will break if you don't have only one configuration of something, you're going to have problems, guys. All right, so escape : WQ. And now we've got SSHD. We're going to restart fail to ban. And then we're going to go look, and we're going to see that fail to ban is running, and it's started a jail, and it's doing whatever it's going to do. So we're going to test that fail to ban is properly working by trying to connect back into the control plane server. So we're going to SSH over to node 01, which is another node in our cluster, and we're going to try to come back in, but we're going to use a for loop, and we're going to use some fake user that doesn't exist. That's it. I'm locked out. I can try it again. Can't even get the connection. All right, so we exit back because we had SSH'd out, so we can exit back. And let's go look at our varlog fail to ban and see that we turned it on. We see some stuff happen, and then we see that the jail started, and we should see the ban occur right here. There's our ban occurring against that user, or against that IP address. We're going based on IPs that are trying to connect to us. So 10.244.6.67. And we're going looking in here and say, yep, we got one banned, 10.244.6.67. That's what we saw in the log as well. And then now we can unban that. We can say fail to ban. Client. Set SSHD, that's the jail that we're using. Unban IP, and then that IP from earlier, and we've unbanned it. Now we can SSH to node 01, and we should be able to SSH back into control plane with no issues now. Oh man, I don't know how I keep turning that on. I think I know how I'm doing it, but anyways, we'll exit out, and we'll be back in control plane. So we've set up the first part, which is going to properly ban things that shouldn't be coming in based on their IP address, in fact. So it's looking at your IP address, not the user. So you might ask, wait, if you used a different user, nope, you're banned on your IP. So those are two different things, right? You've got your users up here being created by the system, but now you tried to log in. Even if you try to come in as the root user from node 01, you're not getting in anymore. You're not even getting to port 22 anymore on that box. Doesn't even give you a header back. We could test that, but all right. So we've got that first part set. Good. Now we're going to set up Grafana and Loki. So this is all the same stuff from before, so we're not going to spend a lot of time digging into what happens, but we got to have some software dependencies, so we'll go ahead and install those. Get our software dependencies downloaded. We'll download the key ring, the GPG key, to validate that things have been properly signed by this host, and then we'll go put that in our repository, and then we're going to install Grafana. Simple, same thing that we did earlier. We're going to install the Grafana system. Take a few seconds. All right. And by the way, I think I missed some follows, but thanks for the follows, guys. Hopefully this stuff's useful to you. Best thing you can do if you want to get involved with the community that we have is just go hop down in Discord and talk to people and ask questions and that kind of stuff. All right. Most of the guys won't bite your head off. Most of them are pretty good about working with new people. We've got Grafana working, but for about 10 seconds, we won't see. Oh, there it is. It's starting to listen. We'll grep again. There it is. It's listening. So it's listening on the right port. We see everything. We can now go into Grafana, this is a new, these are all the old instances. We got to get rid of those. Those aren't even running anymore. And we'll see our new Grafana come up. And we're going to go connect to it. We're going to reset the password to a password that we want. And admin to get in. And we are going to say don't want any of that. Set a new password. New password. Perfect. Don't save it. All right. So we've got Grafana up. Now we're going to make a directory for Loki, cd into Loki, download Loki, make sure that he's there. We're going to copy in our local config and start the daemon. And then we can go look at the local config. It's that same one from earlier. And then do an etcd system service. And then we're going to start the service for Loki. Make sure Loki's running. Cool. So Loki's sitting there. Grafana's sitting there. We've got some of the same components from the last time we did this. And now everything's good. So it says right here, in your research, you find that Promtail can push logs over to Loki in real time. Your task will be to display or to deploy the configure Promtail to push logs over to Loki server and make sure that everything's running. So we'll make dir Promtail, cd in there, download it and unzip it, get the right configs for it. Here's this fail to ban config. This wasn't here before. And it says that it's going to be var log fail to ban.log. So there's our logs. Then we come over here, we do a daemon reload. Whoops, we'll go ahead and copy that in. We'll do a daemon reload. And then we'll check to make sure Promtail service is running. Okay, so Promtail service is reading from that log now and can send it, and we can go all the way through. So now we're going to go configure a dashboard inside of Grafana. It's going to be that same dashboard as we did before. So we're going to go over here. We've got to set up Loki connection. So Loki. Boom. We're going to hit new data source. Loki is always on our system 127.0.0.1. On other systems, it'll be whatever the Loki server is as an API endpoint in your environment, right? Save and test. There's Loki. Cool. That's what we wanted. Come back to home. Make a new dashboard. It's going to be import that same number, 13639 that we saw earlier, and then point it at that data source. All right. Cool. Now we have auth, fail to ban, and syslog. Fail to ban's already there because we already configured it. So here's our fail to ban. And the question is, can we see new failures happen on the system? So we see the server start, we see the jail start, we see a bunch of stuff happening. We see that unban that we just did. But let's go ahead and say 1743.32. Let's go in there and cause something newer than this, right? We'll even maybe open that one. I think if we open that one, it'll show the other one. So let's come over here, and I think the next check is to do the same thing again. So I'm going to go back to node 01. We just bang SSH, and that would do the same thing. Oh my gosh. There we go. Took us 45 minutes, but let's go see about if we do this again. Get ourselves banned out forever. Do we see that over here? So we had there's our last unban request. Now we didn't set it to every 10 seconds, but now in a few seconds we're going to see something newer than 1743.32. When this refreshes, you're going to see the newer stuff in there, and you're going to see that it's rebanned. So there's all those things, and there's the ban of that IP address right there. So that happened, 2.5 minutes out, or 2 minutes after that other one, and those are all of our bans that happened in the system, or all of our findings, breaking stuff, ban, right there. All right. So that's the whole lab, I believe. Yep. Look at you learning Linux. You set up fail to ban, jail, and test it with SSHD, and then track the logs with Promtail, Loki, and Grafana. reflection questions. Read about what an IDS, intrusion detection, and a IPS, intrusion prevention, is. Okay. Read about what does failed ban qualify as an IDS or an IPS? Why? Okay. More reflection questions. What other things might we pull out of here? You had 40,000 banned IP addresses and failed to ban. How might you find the one that you want to unban without unbanning more addresses than you expect to? And maybe you might filter it. You might do a grep on the log. You might ask somebody specifically, like and you guys might say, Scott, how often do you have to do fail to ban commands? I probably do fail to ban commands about once a week when people ask me to get into we have the Prolog lab servers that you guys can get into, and my Bastion node has a fail to ban set on it, and if you try to log into it too many times, you'll get kicked out forever. And then I think I have it set to 5 or 10, maybe I have it set at 5. And anyway, so if you get banned out forever, it doesn't matter unless you reset your IP that you're going to be able to get in. Since most people don't want to or don't need to reset their IPs, their way of getting into my environment is typically just to message me, and then I can send it and fix it for them. So I just go in and I find their I just have them send me their IP that they're using, and then I validate that it's there, and then I wipe it, and then I let them know you can get in there again. Make sure you're using the right password and stuff, right? So, and then you guys that say, well, if that's really running on your system, you got to be banning stuff all the time. We absolutely ban stuff all the time, right? In my home lab, here's the last 6 hours of people that have gotten themselves banned forever, right here. That's the last 6 hours since 11:52. So yeah, that's in the last 6 hours right there. Probably close to 100, if I had to guess. Yeah, it's probably pretty close to 100. But we always have, if we go to my security, then you see all the 40,000, we're at 52,000 that have been banned now. And this is how many get banned at any given time, right? And we can go dig in on any specific time we wanted. If we wanted to see certain, we see spikes and attacks and all that kind of stuff, just from random things on the interwebs, right? So, all right. Anyways, that is that lab. Get rid of that. Ranger's not on his bed. Where's Ranger? All right, all that stuff. Courses all there for you guys to do. Do I have any other questions I want to ask right here? So in your failed to ban configuration, could you change the number of times before someone gets banned to 20 from these? You've got enabled true max retry 5, find time within a 10-minute window. So there's actually a find time, and then ban time. Can you test that? Can you set the ban time to 1 year? So you might have to do a little bit of looking up stuff for that, but I think that that would be valid. Okay. So I think that's a good one for the fail to ban monitoring. I think that one's kind of short and sweet. And then for people that are doing the security engineering course, this is part of the course, and then I have all kinds of other stuff for you guys to do in the course. But this is specifically right here. These things are specifically going into the book. So since they're going into the book on LeanPub, then I want them to. These are all the new labs that I've built in the last few months, right? I want to get them up there so that, you know, if people do buy the book, which is the only book that anybody can buy. These other books are all free right here, right? These are all free, like hundreds of pages of free stuff. If people do buy the book, I want them to have the most updated stuff that's in our kind of little course setup or whatever. All right, we still got the enterprise Ansible patching to do, and I need to update that one with a log. Being able to send with yeah, that's fine. Metric alerting is going to require us to get the what's it called, the webhook out, so I'll have to do that. OS Stig remediation doesn't need any of that, so maybe we'll go do the OS Stig remediation. That might be a fun one. Yeah, let's do this one next. This one should be good. Where's our OS Stig remediation? Ah, with Ansible no less. So, if anybody wants to do this lab with me, here it is. They're free. Killer Coda doesn't charge you nothing. So, I mean, I guess free is worth whatever your time is worth. But if you're hanging out with me, I mean, your time is worth, you know. I would rather be sitting here doing something, like learning something with my hands and practicing, than just sitting here watching. But I guess that depends on, you know. Everybody's got their own stuff. All right. Given a Linux system, deploy an Ansible playbook to secure the system according to Stig standards. Execute and understand commands. Let's see. All right, so your team has to integrate with the U.S. government system. If you ever have to do that, you have to follow certain security protocols. That's always true. There's a security requirement that you need to Stig your servers to a certain score. You have decided to remediate using the DoD Ansible playbook provided by the U.S. government. Okay. Download and unpackage the playbook. Investigate the playbook default values and tasks. All right, so we're going to make a directory called root stigs and cd in there. And then we're going to go download. Oh, they went to 24. I might have to change this one. All right, we're going to, we might change this lab a little bit while we're sitting here. But anyways, let's unpackage what's there. Extract it, cd into Ansible, or make dir into Ansible, and we'll move in the one zip in there, cd into Ansible, and did I cd in there and then unzip it? Yeah, so that was one command. Now look at all these things that got unpackaged in this little directory that I find myself in. We've got Ansible config, we've got roles, we've got the site.yaml. Site.yaml tends to be how you're going to run whatever you're running. And then this is 24, although we are now on 2404, so this lab was written and then the devices changed around it, so that's fine. And then we can go investigate the Stig playbook in here. We can cd to tasks and then look at main.yaml. You know what? It might be a little easier Get out of here. There we go. More main.yaml. It might be easier to do this in Vim. And in Vim, it'll look a little more colored because it's YAML, right? So populate package facts. Here's a bunch of things that are going to happen. And they have each name tied directly back to the Stig rule. So it's kind of nice. But they also have, if we go up one, they also have all the defaults. And we're going to Vim that too. And in here, here's all the defaults. So if you want to change the behavior of something, or you want to make it managed or unmanaged, you can do that right here if you know your Stigs. Now, all your Stigs can be looked at out of your Stig viewer, and you can go download those from the DoD site for that. It's all pretty straightforward. But we do it in other labs, so I'm not doing it right now. But escape : Q, we don't want to change anything. And if I feel pretty good about all of that stuff, I'm going to come back up here, and I'm going to run the site.yaml. So when I'm good, we'll connect, and then it says you're ready to run and see the effects on this server. So we're going to CD to the right location. We're already in there. We're going to look at the enforce.sh, which is just a simple script that calls the Ansible playbook and does all the things it needs to. We're going to make that executable, and then we're going to call it with time and see how long it takes to run against this system. It's going to start to give us information about all the variables that it's called in. It's starting to install different things that it needs to work. So installing audit D. It's probably going to install a whole bunch of things. It's going to touch some Stig rules. When we get all done to the end, we're going to see how many things were changed, right? We're going to see a bunch of this stuff in this playbook that got changed and that kind of stuff. It says right here, how long did the playbook run? Did the playbook break, or did it complete execution? If it does fail, where is it failing? If it's on a handler, does it really matter in the hardening process? And the answer to that is no. The handler really is only dealing with a restart or something after. Handlers don't change things like tasks do. So if something fails, if you were doing a configuration of a server or something and it failed on a handler, for me as like an engineer, like let's say we were doing like a deployment, I'd be like, we got to fix the installer for the next deployment. But the deployment worked. Yeah, that restart, maybe I got to go restart a bunch of boxes with a Ansible ad hoc or something. But the point is, I would know to fix that for later, that handler that was busted, but I wouldn't say that the deployment failed. I would say that the execution of maybe the overall deployment tasks failed, but the deployment itself was successful, because by the time you get to handlers, you're outside of that, if that makes sense. That's how I would view that. At least if I wrote it. If somebody else wrote it, I'd be like, go fix your stuff and do it again. No, I'm just kidding. I'm only kind of kidding. But yeah, if it does fail, where is it failing? Let's just see, right? That we downloaded this off the internet. This is a internet Stig. It's the government Stig for Ubuntu 2004. Let's see how close we can get this thing to some Stig standard, right? It's changing a good number of things. securitylimits.conf, audit rules. All of those Stig rules are well documented, and we can go look at them in the Stig viewer if we wanted to. That's a separate application that you can download for these different systems, right? So Stig rule, UFW, yep, all the different Stigs. Do we need to put AppArmor on? If we do, can we install it? Is it installed? Right, we can go check all those things, right? And you don't have to sit there and watch all this. You can go, I don't know, take a break or something. But I like to kind of watch my stuff run to see if it breaks anywhere, to be able to, quickly reset something and get it going again in case it broke. Because if I go walk away and this thing stops running, but I expect it to be done in an hour, every minute that I'm gone away from this thing is time wasted, right? Because then I got to fix it and get it going back up again. It's doing something with AID, which is the Advanced Intrusion Detection Environment. It's the successor to what we used to call Tripwire. Tripwire was a great tool, but it's doing something with AID, and typically with AID it's checking its database, so this can take a while. AID database is pretty expansive. Speaking of, I'm pretty sure we have a lab that deals with AID. I may have missed a Did I miss something? We'll go look at the labs again, because I remember setting up a lab that did aid. So I feel like I might have missed when I was going and grabbing all the new labs. I might have missed the one on aid. All right, it failed on a handler, but it took 3 minutes and 45 seconds. And again, a handler, that's at the end of the playbook, so it didn't restart SSH. I don't really care all that much. But it changed 94 things, and it found 118 things in a good state. Then it skipped some things, and it failed on the one. That's okay. Then we would go rerun the Stig score that we do from one of the other labs, and we would see how much better we got. Because by default, this box is only like a fucking 38 or something. It's really bad. You want to be over 80% to even connect to a government system. 90 is really kind of the standard we try to get to. Where does it fail? Why is it failing? All of those kind of things. And then it says, look at you learning Linux security. You deployed this, and you watched it happen. So, okay, so anyways, over here, reflection questions. Let's go back. And when you are in, let's go back one more. When you're here. When you're in what are the five directories you see? Can you go into each directory and vim the main.yaml? Right, so like cd files. And vim the or other that you find. What are the purposes of each of the directories, and does this align with what you know about Ansible? If the, how long did the playbook take to run? Oh, actually, hold on, we gotta. Oh, that's fine. What was in the script? What were the Ansibles given, or what were the values given in the script enforce.sh? How long did the playbook take to run? Did the playbook how many changed values were there in the playbook? All right, I think that's pretty good for that. Digging deeper would be, think of what a digging deeper question might be for this. So if you rescan the system according to this other lab, how much better might you expect the output from the original output? And do you remember what the original output is? You might have to do that other lab for that. If you rescan the system according to that, yeah, good. All right, I think that's good. Yeah, we're definitely missing. I'm missing something. Hold on. There's a lab that we did on. Failed to ban, Kafka, usual. Maybe I made you guys do aid on a hammer box. Let me go look. I gotta go find. Shoot. Now I gotta go look for this. Which I'm pretty bad at. Oh, okay. I just made you do 8 on a normal Rocky box. Oh, I made you guys just do it in a normal scenario. Okay. I didn't. Okay. I didn't make my own scenario for it. Okay. Could just make this its own scenario. I made you guys do that. Okay. Okay. Yeah, I guess the question is, do I want to turn that into its own lab, or do so? Here, I made you guys just do it in the playground scenario. Just go in by default. If I turn it into a lab, then I can put it in the book. Otherwise, it just stays over here in the security course forever. Which is, I mean, still, I think this is still valid. Installing aid and then looking at what it takes to build out aid on a system. I think that's still. That's still useful. Yeah, I don't think I'm gonna make that into a lab. Just leave it as this lab in our security engineering stuff. Alright, where's Ranger at? Ranger is not around. Okay. Alright guys, I've been talking for 3.5 hours. So, this is all, is this up in meeting notes? Let me go look. I may have been putting this up in meeting notes. So, never memes jokes. Don't pull that one up on stream. Meeting notes. Did I add this? Yeah. So this one, I'll just, let's edit this. Oh, actually, no, it's funny. It's going to take it. No, let's do it this way. Hold on. Let's pull this up. Control A, Control C. Come over here. Delete. Yep. And then I think, oh. What? All right. Well, I'm pretty sure that I have the ability to just do, well, we'll worry about that later. We'll get that back up in the Discord later, another time. I think the guys are still, man, look, they're still down there studying. Look at them go. All kinds of studying going on down there. You guys should definitely go hang out with them, talk shop with other people that are, most of them are either in the industry or trying to get in the industry. I think of that group I just saw, they are in the industry or adjacent to the tech industry, and they're trying to get over into other roles or that kind of stuff. So it's all, I think good to rub elbows with those guys, because those guys are the ones that are really working at getting better at this stuff, right? Sometimes I get a little cynical about it and I just kind of like sit back, but like a lot of these younger guys or newer guys to this are trying to get really good at it. So you'll find some good conversations there, I think. Okay. How many more do we have? We have the fail to ban with metric alerting, And then might do this one so I can get a better digging deeper section. And then failed the bandwidth metric. Yeah, and then the bottom one. So we got 2 more of these to do. I will probably call it a day here and go raid somebody over on the Twitch side. But for people that have stuck it out and hung out, hopefully this stuff's useful to you. We are, focused on learning the things that we need to learn to get the job. I'm not interested a lot of times in hanging out and talking about who's the smartest guy in the room. You guys will see me sit around and not necessarily care about that kind of stuff. You'll if you hang out long enough, you'll just see like everybody on the internet that's smarter than me will show up, and I'm like, oh, I know I'm not the smartest engineer in the room. I've been an engineer for 22 years. I know exactly where I fall with most engineers. But I also know I'm very good at building stuff, and everybody likes working with me typically. So I know where I fall in that. So the reason I bring that all up is just to say, like, we don't have to sit around and measure it every time we get in a room together, which is, we were talking about it. That happens a lot with security people, and security people tend to think they're Linux people, but they're not. They just have to use our tools sometimes, which is kind of funny. Or security people are not natively Linux people. Let me say that. Although I do think Linux people are natively security people, because we always have to be security minded in what we do. So, anyways, all right, we're not gonna get too much into that, but let's go find somebody to raid. I don't really care too much about all that stuff, but let's go find somebody to raid over on the Twitch side. I appreciate you guys all coming, and I will see some of you guys tomorrow. I'll be on tomorrow doing stuff. Let's go raid Rob. We haven't seen Rob in a while, so we'll go raid him because he's back streaming again. So again, I will see some of you guys later, and the rest, we'll be on this weekend doing a bunch of Linux stuff. Take care.